Hello and welcome to this course on the Django framework. Many of the activities you do every day can be entirely performed online. You can use applications on your phone, computer, tablet, or other devices to access the web. In many web applications, the data is stored in a database, and this data can be accessed on the web server by a programming language such as Python. Once the data is retrieved, it can be then sent to the end users inside web pages using HTML. As an aspiring developer, you have some existing knowledge and skills with these technologies. Now is the time to level up these skills by combining them to create a dynamic web application using the Django framework. Django is an open-source web framework written in Python that is used to build large-scale backend web applications. To work with Django, you will need a good working knowledge of databases, Python, HTML, and CSS. However, you will also need to learn about many new tools, concepts, and workflows. In this course introduction, you may encounter many new terms, but don't worry if you don't fully understand all of them. During the course, you'll explore these concepts in more detail, alongside the many other tasks that form the duties of a Django developer. To assist with your learning, you will take on the role of a junior developer working in the development team for the restaurant Little Lemon. In this fictitious role, you will encounter many real-world scenarios. Applying your newfound knowledge, you will work through these scenarios, overcoming challenges by implementing solutions. As your skill set grows, you will focus on the tools of the framework, how they are used, and why you need to use them. For example, Little Lemon recently launched its first website, containing some HTML, CSS, and JavaScript. Adrian, the co-founder, knows that as the company grows, so must its website. In the future, he wants to transition from a static website to a web application. The main goal is to store all content in a database and provide user access. As a result, he has asked your team to build the next version using the Django web framework. Your job is to use your existing knowledge of Python, HTML, CSS, and databases to explore the features of Django. Then, you will build a prototype of the new web application using the framework. You will then present this prototype to Adrian and the rest of the development team. This course consists of 5 modules. Let me introduce them briefly now. First, you will get an introduction to Django and why it's a popular choice for backend development. Next, you will explore the concept of views to create logic to present data to the end users. In the next module, you will dive deeper into your learning by exploring models. Once you are comfortable working with models, you will learn how to work with templates. Finally, you will put your new skills into practice with the graded assessment to create a basic web application. Now that you have a general understanding of the structure of the course, let's explore each of these modules in a little more detail. In the first module, you will be introduced to the concept of a web framework. You will learn how to create a Django web application and how it is primarily composed of 2 components, projects and apps. Then you will learn how to create and work with projects and apps using specific command line tools with the commands Django admin and manage.py. You will put your newly acquired skills into practice to create an app inside an existing project using the correct structure. You will conclude this module by expanding upon web frameworks to show the MVT pattern, code reusability, and how Django's project structure is set up to suit this. In the next module, you will explore views. You will learn about what a view is and how to process basic HTTP requests. Then, you will discover how Django developers use the request and response objects for common operations. You will learn how to differentiate parameters and how they associate with HTTP methods such as get, put, post, and delete. Then you will explore the use of regular expressions to create different URL patterns and map URLs to views. You will list common HTTP errors and handle these errors at the HTTP, view logic, and view levels. Lastly, you will learn more about class-based views in Django and how to reuse them across a project. In the next module, you will fully explore models. You will learn how to use the Django admin panel to add and control the permissions of users and groups. Then, you will explore how to use the QuerySet API to interact with the database. You will create a form and use the Form API to bind data to objects. Finally, you will learn how to set up a MySQL database and apply migrations to keep your data up to date. In the next module, you will fully explore templates. You will learn how to create templates and use the template language to create markup. Then, you will explore how to use templating to generate HTML. Next, you will learn how to integrate third-party libraries into your Django app. You will end off by exploring debugging and testing in Django. In the final module, you will have an opportunity to recap the key elements of the course before taking the course project. In the project, you will create a data-driven web application for the Little Lemon restaurant. Okay, so now you know what you will be learning. Let's take a quick overview about how the course will be delivered to you. There are many videos in your course that will gradually guide you towards your goal. Watch, pause, rewind, and re-watch the videos until you are confident in your skills. Then, consolidate your knowledge by consulting the course readings and put your skills into practice during the course exercises. Along the way, you'll encounter several knowledge quizzes where you can self-check your progress. And you're not alone in considering a career as a Django developer, which is why you'll also work with course discussion prompts that enable you to connect with your classmates. It's a great way to share knowledge, discuss challenges, and make new friends. To be successful in this course, it is helpful to commit to a regular and disciplined approach to learning. You need to be serious about your study and, if possible, map out a study schedule with dates and times that you can devote to attending the course. It's an online, self-paced course, but it does help to think of your study in terms of regular attendance at a learning institute. In summary, this course provides you with a complete introduction to Django and is part of a program of courses that lead you towards a career in back-end development. When building web applications, developers and development teams have two choices with the code: build everything themselves or use something called a web application framework. You can think of a web application framework as a toolkit containing all the components needed for application development. By using a framework, developers and development teams can focus on the application's unique features instead of spending time developing features common to all applications. For example, developing code for user login and authentication, or building an admin dashboard. In this video, you will be given an overview of the Django framework. You will also learn about where Django is used in the real world and the types of web applications that use it. Django is an open-source web development framework. It's written in Python and was first created for a newspaper publisher web application. As a result, it's excellent for building projects that require high volumes of text content, media files, and heavy traffic. The open-source nature of Django has resulted in its rapid growth and adaptation, which has resulted in its usage for a wide variety of web applications. The Django framework allows easy integration with many tools and languages with support from other Python libraries. Much of the success of a web framework relies on its ability to provide robust, secure, adaptable, and scalable functionalities. Django caters to all of these requirements and provides features like templates, libraries, and APIs, which are all easily manageable and scalable. Along with the publishing industry, Django is also a popular choice for e-commerce, healthcare, finance, transport, travel, social media, and much more. Its power lies in its ability to separate features, which is helpful for organizations that need to create projects using more than one framework. For example, developers can create a back-end framework with Django that can connect to a front-end framework via an API. Organizations are then free to choose whatever front-end framework they like, such as React or React Native from Meta. On the back-end, developers can make use of powerful features. These include an email system for notifications, data analysis tools, admin dashboards, and development tools for online marketplaces and booking systems. As a result, it's no surprise that the Django framework is the choice of some of the world's leading companies and internet giants across various sectors. These include the areas of machine learning and artificial intelligence, scalable web applications, software as a service applications, over-the-top media platforms, and industries like shopping, event management, news, and publishing. Let's explore each of these areas now in a little more detail. First is the domain of machine learning and artificial intelligence. Developers can use Django to deploy machine learning algorithms that can be made available with the help of APIs, Application Programming Interfaces, RPCs, Remote Procedure Calls, and WebSockets. Don't worry about these terms for now. You will learn about them in the course. Django can handle many API endpoints, each of which can have several ML models. Django also enables fast integration and deployment of these models. Next is scalable web applications. An important reason why Django is so popular is its ease of scalability. It's common for many web applications and tech companies to start on a small scale, but soon expand rapidly. For example, an organization building a social media app. Many popular social media apps like Instagram from Meta use Django to meet these rising demands of memory and resource management. The principle of scalability is equally helpful for web applications, where the size of the app's user base is unknown. A critical factor of an app's ability to scale is the ability to provide fast and efficient traffic management for its users. For this reason, Django is popular for applications such as social media, magazines, and blogs. Most applications that are built on the web provide some form of service. For software as a service, or SaaS, applications, this can mean platforms that provide things like data storage, app stores, and version control systems. For example, Django is a popular choice for cloud storage applications because it provides something called asynchronous views. This allows the application to run different services concurrently instead of waiting in the queue to complete each service, significantly increasing the application's performance. Finally, let's explore over-the-top or OTT media platforms that provide audio and video streaming services. OOT platforms have grown in popularity recently, and Django is often used to meet their needs. It's important to note that Django is not just limited to the services and sectors mentioned in this video. However, it's generally considered that Django is more suitable for large projects because it provides good fault tolerance. Also, its open source nature is inherently free, drastically reducing companies' costs. Also, the ease of adaptation, robustness, supportive open source community, comprehensive documentation, and security make Django popular. Ultimately, developers and organizations favor Django because, just like Python, it helps them avoid reinventing the wheel. In this video, you were given an overview of the Django framework and why it's favored for building web applications. You also learned about where Django is used in the real world and the types of web applications that use it.
I don't think it was actually named after Unchained. It was named after the guitarist. But I'm going to fact check myself before I spread a bunch of... Oh yeah, it was Django Reinhardt. Okay. My name is Jeremy. I'm a software engineer at Meta, and I work in the integrity space. I'm a big advocate of learning about technology that's actually used in real life, and Django happens to be the most popular Python web framework. Django is a framework that lets you process HTTP requests from end users and eventually return back content back to them, say, for example, an HTML page. So Django is what powers this sort of interaction from the user requesting data or sending data to us processing the data and giving them back some more data. Django is actually the first web framework that I personally learned. I used it for hackathons in college as well as undergraduate research. And the reason that I used it is it's super lightweight and easy to spin up. Django comes with a bunch of tools already built in as first-class features inside of the framework. So what I mean by that is there's already a bunch of code that's within this framework to do things like interacting with a database or processing HTTP requests. So I would say the difference between a framework like Django and Flask is kind of a matter of preference. I would analyze what you need. Do you need something that's really lightweight that just takes an HTTP request and returns stuff out? And you don't need stuff like database management, then I would go with something like Flask. But if you want a lot of stuff for free, if you're trying to build, for example, a website that might interact with a database, and you're trying to do this really quickly to create a rapid prototype or minimum viable product, Django is a great candidate for that. Maybe one of the biggest challenges of Django is there is a learning curve to it. It comes with a lot of different tools built in. It requires you to learn what all of the different features of them mean. So one reason I'm a big advocate of learning Django is it kind of gives you exposure to what we call the full stack. That means you'll learn a lot about how to interact with a database, how to make front-end code that actually gets returned out to the user, so that's what they actually see, as well as writing, obviously, web server code, which kind of wires these two components together between your backend database and your front-end client. And the web server sits in between, meaning you'll get full exposure to how the entire software development cycle works. I would actually say the best way to get better at it is to learn by doing. That's why I'm a big proponent of having things like personal projects, even if the project itself isn't super useful to anybody. I myself have built a lot of useless projects out there just for the sake of learning different frameworks. For me, that's actually made me a much stronger developer over time. I'm a big advocate of coding alongside the course as you go. And the reason for that is things in software development tend to not stick very well if you passively watch. So if you do stuff interactively, so that's taking examples throughout this course and actually trying to build them out alongside or doing your own personal project, I think that'll make your learning a lot more sticky, but also more accelerated. I hope this has added some color on how Django is actually used in industry, and I wish you luck as you continue on your journey to becoming a more well-rounded software engineer.
When learning web development, it's important to understand what is required to build a website. By now, you should be familiar with the basic structure of a website. It contains web pages consisting of HTML for the page structure, CSS for the look and style, and JavaScript for client-side interaction. Suppose you are creating a static website. The project structure may only need some CSS, JavaScript, and image folders. This approach may work fine for a simple static website. The purpose of the project structure is to lay out the files in a way that makes them easy to update. However, when dealing with web applications requiring more complex functionality, such as the need to hold state or access and store data, things need to be set up differently. Using a framework, developers can focus on creating functionality unique to the projects, instead of repeating the repetitive coding tasks associated with building a web application. Django was created by developers who have followed best practices. It allows you to set up your web application in a structured way for easier development. In this video, you will learn about the core concepts of projects and apps in Django, and how they provide a structure for a developer to work from. Okay, so before you explore the structure of the Django framework, it's good to fully understand what is usually required to create a dynamic web application. This can involve working with internet protocols, web server configuration, and data retrieval, or storage. Let's recap these concepts quickly. Regarding internet protocols, recall that HTTP is used to get, send, and render web content. Understanding HTTP is essential in web development, as every action is always tied into a HTTP request, pointing to some URL. A web server is required to get the page users want and return it to them via HTTP. Django comes with its own development server, which is written in Python. This will save a developer a lot of time and avoid any messy configurations. Recall that the web is stateless, meaning it does not store anything for future reference. So, a database is required to keep and retrieve the data associated with the website. For example, every time a user submits a form on a site, this data will need to be stored so it can be retrieved and rendered later. Okay, so now you have learned about how a framework provides a structure for a developer to work from. Let's explore the structure of a Django project. In Django, a project represents the entire web application. Django provides a set of commands that auto-generates a project structure that contains the configuration and setting related to the entire web application. You will learn more about this project structure later. For now, just know that it's a way to organize your Python files and folders. This allows developers to focus on code rather than configuration. Okay, so now you know about projects. Let's learn more about apps. In Django, an app is a submodule of a project. It is typically used to implement functionality for some specific purpose. Apps can be self-contained, meaning they do not rely on other apps to function. As a result, they can be used or reused in many different projects. This leads nicely to the don't repeat yourself, dry principles. Write it once, but use it many times. As an aspiring developer in Django, this might seem confusing when you encounter the terms application and apps. Just remember that a Django web application is a project that contains many apps. For example, suppose you are creating a social media application. Well, in Django, the social media application would be the project, and the different features would be represented by the different apps. So, you could create separate apps for the newsfeed, the comments, the friends list, the user page, and so on. Apps are added using the start app command. And like with a project, Django also automatically generates a self-contained directory and its associated files inside the project structure. For Django to recognize an app in a project, it must be added to the installed apps setting. Additionally, a Django app is a set of code that interacts with various parts of the framework. There are a few places where Django needs to interact with installed applications. This is mainly for configuration and introspection. That's why the application registry maintains metadata in an app-config instance for each installed application. Applications usually include some combination such as models, views, templates, template tags, static files, URLs, and middleware. Don't worry if you do not understand all these terms yet. You'll learn about them all later in this course. For now, just know that as a developer, you will spend a great deal of time working with apps as they contain all the project's different parts. And as a developer, deciding what constitutes an app in a project can be subjective, and you may encounter various approaches to app design. For now, it's best to think that an app should be feature-targeted and is best suited to one thing and one thing only. And throughout this course, you will be working with a project that contains only one app. In this video, you learned about the core concepts of projects and apps in Django, and how they provide a structure for a developer to work from. By now, you should be familiar with the concept of projects and apps in Django. You also explored the core files that make up a Django project. In this video, you will learn how to create your first Django project using the terminal and the VS Code editor. You will also learn how to set up the development environment by installing a virtual environment. And you will explore some common CLI commands used to create Django projects and launch the development server. If you are a Python developer working on multiple projects, it's best practice to keep your projects isolated in a virtual environment. But you may be wondering why you need to do this. Well, Django projects can often be quite large and involve specific dependencies for things like packages. For example, you could have a package that has a dependency on a specific version. You do not want this conflicting with your other Python or Django projects, so it's best to keep your projects isolated using a virtual development environment. Virtual environments are isolated spaces you create to manage dependencies and the overall project. This allows you to keep features such as the interpreter, libraries, and scripts isolated and installed for a specific project. In addition to the functionalities provided, Django also comes with an integrated development server. This means that the application has a request-response relationship with a client. Okay, so now that you are familiar with the concept of the virtual development environment and development server, let's explore the steps involved in creating a Django project. First, you create a project directory. Next, you create a virtual environment for your Django application. Then, you create a Django project and finally run the Django development server. Let's explore each of these steps now in a little more detail using some examples in VS Code. Your project is an organizational unit that consists of settings and database information. It can be stored anywhere on your development computer, but as a best practice, it's best to keep it in a subfolder with all your other Django applications. First, open a new terminal by choosing Terminal, New Terminal from the top menu. Next, create a new directory by using the Make Directory command, and then give your directory a name, like Build Django. Then, enter inside this directory using the Change Directory command. Next, you need to set up the virtual environment. To do this, type Python 3-m and then venv. Then give the virtual environment a name, such as tutorial env. Once you are finished, press Enter. If you open the directory structure in VS Code, notice that some new files have been generated. Now you need to activate the virtual environment. Type source and the path from where you can activate it, which is tutorial env. Then activate and press Enter. Notice that the virtual environment is activated by the round bracket suffix in the terminal. Once the virtual environment package is installed, you are ready to install Django, and you do this by using the command pip3 install Django. To make sure that Django is installed, you can run the command python 3-m Django version. Notice that the current version is 4.1. Once this is set up, you are ready to create a project, and you do this by running Django's built-in command line tools. Type Django admin, start project, and then give the project a name. In this example, it's Chef's Table. Finally, press Enter to run the command. If you expand the directory structure again, notice that the Chef's Table is created with supportive Django-specific files. Once your Django project is created, you need to launch the development server. Before you do this, it's important to be aware of the manage.py file that is automatically created with the project. Recall that manage.py is a command line utility that works like the Django admin command. So, you can replace the Django admin command with manage.py, as it uses the project settings. To launch the development server, you can run the run server command using the manage.py command. You will learn more about how to work with Django admin and manage.py commands later. Notice that a URL is generated. If you are on Mac, you can click on this URL to open it in a browser window. If you are on Windows, you will need to copy and paste it to your browser. Notice that the terminal gives us an option to press Ctrl-C to stop our server. It's important to know that virtual environments and development servers are extensive topics by themselves, and you will learn more about them later in this course. You can even omit the use of a virtual environment if you wish. But this is not recommended. In this video, you learned how to create your first project in Django using the terminal, VS Code, and Django's built-in command line tools. By now, you should be familiar with the core structure of the Django framework. You know that to create a Django application, you need to create a virtual environment for the project, create the project, and then run the development server. And you do this by running specific commands such as start project and run server, using the Django admin command line utility. Django provides a set of commands that auto-generates a project structure that contains the configuration and settings related to the entire web application. When working on Django projects, developers have two choices for command line utility to perform tasks. They can use either Django admin or manage.py. While both can be used to perform the same tasks, there are some subtle differences, and your choice of usage will depend on how you want to work on your project. In this video, you will learn about the Django admin and manage.py commands, and how developers use them to perform administrative tasks. One of the powerful features of Django is that it provides a ready-to-use admin interface in the form of a command line utility named as Django admin. Django admin is Django's command line utility for administrative tasks. This utility is present in the scripts folder of the Django's environment directory. The Django admin utility is executed from inside the terminal. Manage.py is a script that is a local version of Django admin and is located inside the project folder. It sets the Django settings module environment variable so that it points to your project settings.py file. Django admin is a file that is created when you install Django. The Django admin utility should be on your system path if you installed Django via pip. If you do not find it on your system path, make sure you have your virtual environment activated and install Django inside it using a command such as pip3 install Django. Manage.py is a file that is automatically created each time you create a Django project. This file is specific to the virtual environment of the project. It does the same thing as Django admin, but also sets the Django settings module environment variable to point to your project's settings.py file. Generally, when working on a single Django project, developers tend to use manage.py, as the administrative tasks of Django admin can also be performed with manage.py. However, if you need to switch between multiple Django setting files, use the Django admin command with the Django settings module or the settings command line option. The command line examples throughout this video use Django admin to be consistent, but any example can use manage.py just as well. You may recall that you use the start project command to create a Django project. This creates a Django project directory structure for the given project name in the current directory or the given destination. By default, the new directory contains the manage.py file and a project package. This project package contains a settings.py file and other files. It's important to note that if only the project name is given, both the project directory and the project package will use the same name as the project name. Also, the project directory will be created in the current working directory. If an optional destination is provided, Django will use that existing directory as the project directory and create the manage.py file and the project package within it. A common developer workflow is to use the period symbol to denote the current working directory. This avoids having subdirectories with the same name. Recall that you use the run server command to run a project. This command starts a lightweight development web server on your local machine. By default, the server runs on port 8000 on the IP address 127.0.0.1. However, it is possible to change this, as you can pass in an IP address and port number explicitly. It is important to note that if you run this script as a user with normal privileges, which are recommended, you might not have access to start a port on a low port number. This is because low port numbers are reserved for the super user or root user. The development server works great for application development and testing. However, Django recommends that you should never use this server in production, as it has not gone through security audits or performance tests. The development server automatically reloads Python code for each request as needed. You don't need to restart the server for code changes to take effect. However, some actions like adding files don't trigger a restart, so you'll have to restart the server in these cases. In this video, you learned about the Django admin and manage.py commands and how developers use them to perform administrative tasks.
So far, you've learned that a project represents the entire web application, and an app acts like a submodule of the project to provide specific functionality. Previously, you set up the project folder and created the virtual environment inside it. In this video, you'll learn how to create an app inside an existing Django project. The app will contain a view to output some text to the homepage of the web application. So I'm in VS Code with the project open. First, I need to create a Django app for my project, and for this, I use the start app command. So I type python-m Django start app. Then I need to give this app a unique name, so I'll call it something like my app. Before I move on, let's explore the structure of the start app command in a little more detail. The start app command has a default syntax where you need to provide the app label, and then you have the option to specify the destination. Suppose you do not specify any destination, like in this example. In that case, the default destination of the current working directory is used. Okay, so my command looks good, so I press enter to execute it. Notice that a folder called My App is created inside the project folder. If I expand the folder, you will notice that it contains some files for init, admin, models, tests, and views. If you're new to web frameworks and Django, I know that this can seem a bit intimidating. Already, the project contains folders with many different files, and I haven't even started coding yet. Don't worry if you don't understand fully what every file and folder does. It's more important to focus on the concept that you need to create apps to add different features to a project. As this project has just one feature to print some text to a web page, I've created one app to do this. Okay, so now that I've created an app, I want to output some text to the home page. And to do this, I need to work with Django elements called routes and views. When the user visits the application's homepage, I want to display some text. In Django, when a user navigates to a URL, the URL is routed to something called a view or controller. For now, you can just think of views as Python functions that generate the content that makes up the web page. They can receive a request and return a response. And because this request and response will take place over the web, it'll use two objects called HTTP request and HTTP response. Once again, don't worry if you don't understand all of this. You'll learn more about routes, views, HTTP requests, and responses later. For now, just know this is what you need to use for Django to display some dynamic text on a web page. Okay, so first I want to create the view function. I open the file views.py in the app folder and notice that it already contains some code. It's a good idea for now not to modify the code that's automatically created by Django. I just need to add to it. Okay, so I've added 3 lines of code. Let's explore it now. The first line is an import statement, which is required for the request response to work. Then the code to create a function named home. This function returns an HTTP response object containing the text, hello world. It's important to know that creating the function that returns an HTTP response will not do anything on its own. This is just the logic that will be executed when a user goes to the project's homepage. So to make this work, I need to map the view function to a URL. The URLs you will use in your Django project are stored as a URL configuration in a file called urls.py, which is located in the project directory. The Django documentation or your fellow developers may also refer to this as URL conf. You will also explore the concept of URL configuration and its code in more detail later. For now, just know that it acts like a mapping chart that Django uses to determine which view functions are associated with a specific URL. If I open this file, I notice it already contains some code by default. For example, some import statements from the core Django package and a list labeled URL patterns. So it's in this file that I need to add the code to map the URL of the homepage to its corresponding view function. First, I import the view file by typing from my app import and then views file from that app. Next, I need to add the file path to the list. So let me copy and paste line 22 and edit it. I want the view function to execute on the home page, so I can just replace the word admin with an empty string. Next, I need to specify the view function, so let's change this to views.home and add a name such as home. You can think of name as an attribute used for naming the URL patterns, which can be useful sometimes. Okay, so my code looks good now. All I need to do now is save my changes and run the development server. Recall that I used the command run server to run the development server. So you type the command python manage.py run server. Notice that the development server starts at the default IP address, which can also be called localhost on your device. You will also likely receive a warning message stating that you have unapplied migrations, and Django gives you a command to run to fix this warning. I'm not going to do that right now, but don't worry, you'll learn how to do this when you explore migrations later in this course. Success! If I open the web page at the default address, notice that the text Hello World displays. This text is returned as an HTTP response from the view. If I change this, let's say remove the word world and resave, check the web page, refresh it, notice that the page gets updated again. It's important to know that while the content of the view is quite basic, this is the process by which every web page uses Django to create and update content. In this video, you learned how to create an app inside an existing Django project containing a view to output some text to a web page.
As an aspiring developer starting a new web project, it can sometimes be confusing to understand why the project is structured in the way it is. As a result, solid understanding of a web framework and its core concepts is essential. In this video, you will learn to describe a web framework and list the benefits of using the Django framework to build back-end web applications. You will also explore the concept of the three-tier architecture. Frameworks are designed to support the developer in building the web application. The purpose of a web framework is to make application development easier and to provide the developer with a clean structure that keeps things in order and allows for changes and modifications. Frameworks also allow for code reusability, facilitated by existing code. When building a web application, it's important to understand that many different pieces and components exist. For example, you can build a static website with just some HTML, CSS, and JavaScript. However, suppose you want to add e-commerce functionality, such as a shop. In that case, you will have to implement things like user sign-in, payment transactions, security, performance, and deal with data being posted from web forms. This will require your application to split into two parts, the front end and the back end. Recall that the front end is the part of the website the user interacts with via the web browser, and the back end is the part that runs on a web server and usually contains the database. So, if your website requires functionalities such as e-commerce, site users, payment processing, and data stored in a database, it will most likely need a back-end. More specifically, a back-end application to manage the back-end. When choosing a framework to build the back-end, there are many options to choose from. These frameworks all share the common goal of providing features to create a web application with a good structure. If it helps, you can think of the framework the same way you would think of a foundation to build a house. You always need to start with a solid foundation. Without it, the house is not going to be very stable. Web frameworks are precisely the same. They provide a solid foundation to build upon, and one of the most popular is Django. Django is a high-level, free, open-source Python web framework that encourages rapid development and clean, pragmatic design. It's built by experienced developers and takes care of many of the tasks associated with web development, allowing you to focus on writing your app without needing to reinvent the wheel. Let's explore some of the benefits of using the Django framework. This includes speed, features, security, and scalability. According to the developers of Django themselves, Django is ridiculously fast and speeds up the process by reducing the amount of code to be written. This means that you can take applications from concept to completion as quickly as possible. Django is feature-rich and includes many right-out-of-the-box features that you can use to handle common web development tasks. These include tasks such as user authentication, content administration, site maps, and RSS feeds. Django is very secure and helps developers avoid many common security mistakes. It provides a secure layer of internal middleware that protects it from common attacks attempting to steal information. Finally, Django is highly scalable. It allows data to be stored on other servers than the one in use without too many changes in configuration. This provides flexibility and speed, and as a result, some of the busiest sites on the web leverage Django's ability to quickly and flexibly scale. Okay, so now you have a basic understanding of what a web framework is and why the Django framework is a popular choice for application development. Let's explore its structure by learning about something known as the three-tier architecture. Architecture refers to the fundamental structures of a software system, and modern applications tend to be built in what is called the three-tier architecture. This is a modular-based approach to client-server architecture that splits the application into three logical parts: a presentation tier, an application tier, and a data tier. Let's examine each of these parts now in a little more detail. The presentation tier is the layer the users primarily interact with through user interfaces from their desktop, laptop, or mobile devices. It's commonly built with a UI framework or library such as React from Meta, and it communicates with the other tiers by sending results through the application interface. The data tier usually consists of database servers for storing and retrieving information. Any dynamic website needs to be able to store and retrieve data. A database is the best choice as it stores data in tables or objects depending on the choice of database. The application tier is what ties in the other two tiers. It gets data from the presentation layer and persists it in the data tier. It's important to know that these parts are logical and not physical, meaning you can have all three tiers running on the same web server. In this video, you learned about web frameworks and why Django is a popular choice for developers to build back-end web applications. You also explored the concept of the three-tier architecture for building web applications.
You've already learned that Django projects can get quite large. I understand that for an aspiring developer, it's easy to get intimidated as Django projects can have many moving parts. In this video, I'll give you a broad overview and demonstrate how Django organizes a project using models, views, and templates, commonly known as the MVT architecture. Don't worry if you don't fully understand all the concepts in this video, as you'll be learning all about them soon. Instead, please focus on the concept that the data, logic, and display are separated in the Django framework. You can even think of this video as a sneak peek into the future of how developers use the Django framework in backend development. Previously, I created a folder called Building MVT. If I expand it, notice that I've created a virtual environment called Tutorial EMV. I also created a project called Chef's Table and installed Django in that project. Inside the Chef's Table project, notice that I created an app called Little Lemon. And notice that Django has automatically created the associated files for the project and the app. Before I demonstrate the files of the MVT architecture, I first need to update the urls.py file in two places so that Django can match the different URLs to the correct view. In these files, I've added the URLs that will invoke the view functions. Now I will demonstrate the concept of the MVT architecture by using three examples. The first example will contain only views. Next will be an example containing models and views. Finally, there'll be an example with models, views, and templates. Let's begin with the first example that only contains the view. If you open the file views.py, notice it contains a Python function that sends some data to a web page that runs on the development server on a local host. In this example, the data returned is the text "Hello World." Let me demonstrate this now by launching the development server. I open the URL in the browser and notice the text "Hello World" displays. Okay, let me close the browser window and quit the server. For the second example, I've made some code changes to demonstrate how views can work with the models. Notice that I created another function in the views.py file. This function communicates with the model to retrieve data stored in a database table and then dynamically returns it to the web browser. Let's now explore how a model communicates with the database and open the models.py file. Notice that this code contains a Python class which represents a table in the database, and each of the variables created acts like a column in that table. If you're familiar with the concept of relational databases, you might wonder how this is possible. For now, just know that Django maps the code in the class to a corresponding table stored in the database. Okay, let me run the server again. This time, when I go to the URL, the output will display the text pasta, type of Italian cuisine. Django dynamically fetched the text from a database table based on the numerical value sent in the URL, and this corresponds to some entry in the table. At the moment, it has the value of 1. If I change this from 1 to 2, notice that different text is output to the browser. This is possible because of the logic created in the views.py file. For the final example, I need to modify the view to return a template I created inside the app folder. Notice that if I expand this folder, it consists of a file called menucard.html. The file contains 3 HTML elements with some basic styling. In this final example, I have not made any other changes except adding a template and modifying the views.py file. If I open the web page again and refresh the page, the output will display with the HTML and CSS applied. The format and style will be applied to all the pages where I've made the changes. It's important to note that while this output may seem basic, the concept is very powerful. By splitting the data, logic, and display into M, V, and T, developers can rapidly create large-scale, data-driven applications. The MVT architecture allows developers to easily update the database, logical code, presentation, and styling to create dynamic web applications. While the number of files present inside your project folder may seem intimidating, you'll explore these files when you need them throughout the remainder of this course. And as I said at the start of this video, you will soon explore this MVT concept in greater detail. It's also worth remembering you're already familiar with the code you'll be dealing with, as it's primarily Python. In this video, you learn how Django implements the model, view, and template, or MVT architecture.
Congratulations! You completed this module on an introduction to Django. In this module, you were given a course introduction. Then you learned about projects and apps, admin and structures, and finally, about web frameworks. It's now time to recap the key points and concepts you learned and the skills you gained. You began the module by exploring what Django is. You can now identify the problems that Django solves, especially for building projects that require high volumes of text content, media files, and heavy traffic. You can also provide examples of where Django is used in the real world. For example, developers can create a back-end framework with Django that can connect to a front-end framework via an API. Next, you are then introduced to the project creation process. You can now create a project in VS Code using Windows or Linux. Secondly, you learned about projects and apps. You should now be able to explain the core concepts of projects and apps, emphasize the importance of structuring a project to make your development process easier, and get a default web project up and running. You also learned about following best practices to develop projects in a structured way. This includes the don't repeat yourself, DRY principles. Write it once, but use it many times. Thirdly, you explored admin and structures. In this section, you learned to discuss both Django admin and manage.py commands as options for command line utility to perform administration tasks, and how they are used in the creation of projects and apps. You can unpack the key differences between projects and apps and how they can be used together. And you learned how to create an app inside an existing project. Lastly, you focused on web frameworks. You now know that frameworks are designed to support you in building web applications. It helps a development team to follow best practices. You understand that a framework is a solid foundation upon which you build your applications. The purpose of a web framework is to make application development easier and to provide the developer with a clean structure that keeps things in order and allows for changes and modifications. Frameworks also allow for code reusability, facilitated by existing code. You've learned about the different pieces and components that exist when building web applications, and that modern applications are usually built using the 3-tier architecture. You explored Django structures that take care of many web development tasks. These structures allow you to focus on writing your app without needing to reinvent the wheel. Recall the benefits of using the Django framework, including speed, features, security, and scalability. You also learned how Django implements the Model View and Template, or MVT, architecture, and that splitting the data, logic, and display into M, V, and T rapidly creates large-scale, data-driven web applications. Now you can show the MVT pattern while prioritizing the reusability of code. You learned to create an app inside an existing Django project, whereby the app contains a view to output text to the homepage of the web application. What a great start to your Django development journey. You are now familiar with the differences between project structure and apps, the Django admin and manage.py commands, the MVT framework, and creating an app inside an existing project using the correct structure. Well done. If you are building a basic static website, all you need to do is upload your website files to a web server. However, if you are building a dynamic website using a framework, you may need to get or retrieve data and render it to the browser. This data could be anything like the user's name or a list of information. In Django, you use something called a view to create the logic to present data to the end users. In this video, you will learn about views in Django and how developers use them to process HTTP requests and return an HTTP response. In Django, a view is a function designed to handle a web request and return a web response, such as an HTML document. To demonstrate this, let's explore an HTTP request response scenario, using an example of a static file and a dynamic file. For a static file with no dynamic content, the HTTP request just needs to map to where the file is located and return that page for rendering. As the static page does not change, nothing else is needed. Suppose the page is at the address of littlelemon.com/index.html. The web server will process the request and return a response containing the page index.html to the browser, which then renders the content. You may recall that this process is known as the HTTP request response cycle. However, if you want to do the same thing with Django, you need to write a Python function to create something called a view. You create the function inside the views.py file and return the HTML. Let's explore this concept further now and step through the code one line at a time. First, you import the class HTTP response from the Django.http module. Next, you define a function called home, and this is known as the view function. Each view function takes an HTTP request object as its first parameter, named request. As this is a Python function, it's possible to define more parameters and pass arguments, and you will learn about that later in this course. It's important to know that the name you give the view function doesn't matter. The function doesn't need to be named in a certain way for Django to recognize it. In this example, it's called home because defining a function name that clearly indicates what the function does is good practice. Next, you create a variable and use it to store a string containing the HTML to be returned. Once again, you can name this variable anything you want. In this example, it's called content. Finally, you need to return this variable containing the code. And you do this by using the return statement with the HTTP response object. Inside the HTTP response, you place the variable. You can also perform other programming logic inside of view functions, such as processing data for emails and forms, retrieving data from a database, transforming data, and rendering templates. It's important to know that you create view functions inside the views.py file as a best practice. You can theoretically name the file anything that you like, but it is a good practice to keep it as views.py, as it makes it easier for your fellow developers working on the same project. It's important to note that creating a view function is not enough to make the request response work. The view function needs to be mapped to a URL, so when the request to the URL is made, the view function gets called. This process of mapping a URL to a view function is known as routing. To set up this routing to map URLs to views, you will need to create a new file. Inside your project app, create a new file called urls.py. You may recall that the project has a file with this name also. You will learn about the difference between them later. Inside the urls.py file of the app, you first import the path function. Then, from the app directory, you import the views.py file. Notice that both files are in the same directory. You only need to place the period symbol after the import statement. Next, to create a route and map a URL to a view, you need to create a list sequence using the variable URL patterns. This variable is assigned to a list that contains the URL paths that you want to create inside the app. The URL patterns list can contain multiple paths, and each path is created using the path function. The function can accept arguments, and 2 are required. The first argument is the route, which is a string that contains a URL pattern, and the second argument is the view, which contains the relative path and the name of the view function. In this example, the view function is called for the homepage of the app, so for now it's set to an empty string. You will learn more about how to populate the route argument with URLs represented as strings later. In this video, you learned about views and view functions and how developers use them to process HTTP requests and return an HTTP response. You also learned that view functions are mapped to URLs using the path function in the urls.py file of the app. Most websites or web applications provide a homepage when you type in the name of the URL or click on the website link from a search engine. The homepage is returned when only a request for a URL with the domain name is sent. Previously, you learned that in order to accept a HTTP request and return a HTTP response, you need to create a view function inside the views.py file. The view function is then mapped to a URL, and when the request to that URL is made, the view function will be called. In this video, you will learn about URL configuration in Django and how it's used to map URLs to views. You will explore the URL configuration file, urls.py, and learn why it exists at both the project and app levels. Finally, you will learn how to reference the urls.py file at the app level using the include function. To design URLs for an app, you create a Python module informally called a URL conf, or URL configuration. The URL configurations used by the view functions in Django are created and updated in the urls.py file. Django by default creates a urls.py file at the project level, but additionally, it's best practice to create a urls.py at the app level. This way, the respective URLs for an app are clustered, but the project also needs to know what URLs are used inside each app. For example, in Django, when a user makes a request for a URL, this request is first handled by the urls.py file at the project level. Django looks for the variable URL patterns. However, the code that contains the logic for the URL mapping is at the app level. So, you need a way to tell Django to also check the urls.py file at the app level, and you do this by using the include function. In the urls.py file at the project level, you create a new path inside the URL patterns list. Then, inside the path function, you pass a reference to the app level urls.py file as the view argument. This allows the project level to access the app level URLs. By using the include function, the project level urls.py can inherit the app level URL configurations. You will explore this concept of inheritance in more detail later when you work with routes containing URLs represented as strings. Now let's open VS Code and create the code for the URL configuration. To begin, let's create a project. and inside the project, create an app called My App. To ensure that the Django app is running, launch the development server by running the terminal command, python3 manage.py run server. Now, select the URL to deploy Django to your local host. Notice that the web page with a successful install message is displayed. Let's close the web page and stop the server for now. The first step is to open the views.py file to create a view. Using the import statement, type django.http import http response. Next, create a function called home and pass the request object inside of it. Next, return an HTTP response containing a string. Let's use the example of the home page for the Little Lemon restaurant. The message in the string says, "Welcome to the Little Lemon restaurant." The goal is to display the message when the user opens the localhost URL. Let's explore the next steps to display the message. The first step is to create a file inside My App called urls.py. Recall that this is the app-level urls.py file and that one also exists at the project level. In the urls.py file, you need to import the path function from the django.urls. This allows you to use the path function inside the URL patterns list. And it's inside the path function where you map the URLs to its relevant view function. The next step is to create the sequence called URL patterns. Between the open and close square brackets, you add the path function, and inside the parentheses pass an empty string followed by the location and the name of the view function. Because the files urls.py file and views.py file are in the same folder, you only need to provide the name of the file without the .py extension, where the view function is located, and then a dot and the name of the view function. Notice that VS Code highlights the word views in the code. This means that in order to use the views.py file, it must be imported. So, type from.import views and save the file. It's important to remember to add a comma at the end of this path function to match the parsing that Django performs. Now, save the file once more. Okay, so the code is nearly complete. The final step is to set the URL configuration at the project level. This is because the project file doesn't know where the view function is. To set this configuration, open the urls.py of the project. Beside the keyword path, type comma, and then include to import the include function. Next, inside the URL patterns list, add another path function. Inside the parentheses, pass an empty string. For the second parameter, use the include function to pass the location of url.py file of the app. Once again, remember to not add the .py extension. Save the file and open the localhost URL in the browser. Success! The message "Welcome to the Little Lemon restaurant" displays. In this video, you learned about URL configuration in Django and how it's used to map URLs at the project level to views at the app level.
In this video, you'll learn how to create view functions that return text and HTML markup using the HTTP response object. Then you'll learn how to map these functions to URLs so that they can be displayed to the end user in a web browser. By now, you should be familiar with the concept of views and how they're used to create view functions with the logic in the views.py file. I've already created an app inside the project, and the first thing I want to do is return the text "Hello World" on a web page. First, I open the file called views.py and paste in some code. Notice the HTTP response that I imported on line 2. It allows me to communicate with the server. In this video, when referencing the server, I will often use the words request and response. Recall that request refers to requesting information from the server via a code, and response just means that I'm returning an HTTP response to the server. Then the response is displayed on the web page. It's important to know that when I create a view function that returns an HTTP response, it won't do anything on its own. This is because Django doesn't know where to return the content hello world. So to make this work, I need to map the view function to a URL using the URL configuration file called urls.py in the project directory. So let me open this file and add a new path. Once I add the path, I need to import the views.py file from my app directory. Now Django can access the views file and the hello function that I've defined. Notice that the path contains the URL and the name of the function from the views.py file that I want to map to. The first argument that's passed to the path function is the URL location that's added as a suffix to the URL or localhost. If this doesn't make sense at the moment, it will when I preview the web page in the browser. Now I run the server by typing the command python manage.py run server. I can open the development server by clicking the URL for the localhost or copy and paste in the browser. Notice that 404 page not found error is returned. The reason for this is because I added the path of say hello to the URL, so I need to add that now as a suffix. Now when I press enter, notice that a web page is displayed with the text hello world. Now I want to create another view function inside the app. So back in the views.py file, I create a new function called homepage. This returns the text welcome to Little Lemon. Once again, to map this view function to a URL, I open the urls.py file and add a path that will access the views.homepage function. Notice how I've added a new location called homepage to retrieve the content, and this will reflect in the new URL. Okay, so I save these two files and return to the web browser. I change the suffix from say hello to homepage. Press enter and notice that the new output is displayed. You may be wondering, how does all this code integrate with Python? Let me demonstrate this by adding a third view function that accesses the datetime module in Python. Then I need to make sure that I import the datetime module so my code has access. That looks good to me. Now my code has access to the year that uses the datetime module. It's stored in a variable named date_joined. Notice that this value is returned to a web page, and to map it to a URL, I once again open the urls.py file to add the associated path. Once again, I save the files. Now, when I visit the web page, I can access the URL with the suffix display date. This displays the year. I'm happy with the code so far. However, there is one last view function left for me to add. Back in views.py, I add another function called menu. This code allows me to pass HTML code inside an object in Python, and I can return that object as an HTTP response. Notice that I've also added some styling by changing the color of the code. I save my file and once again create the path. It's important to remember to always save the files after every update. Now let me revisit the web page again and go to the URL I've created. Notice that the text displays with HTML markup and some CSS styling. In this video, you learn how to create view functions that return the text and HTML markup using the HTTP response object. Then you learned how to map these functions to URLs so that they can be displayed to the end user in a web browser. While at the moment the content returned is basic, later in the course you'll learn how to return more complete web pages using templates. Good luck as you continue your development journey.
Have you ever noticed the lock icon beside the URL in your web browser? This means that HTTPS, the secure version of HTTP, is being used. HTTP is a core operational protocol of the World Wide Web. It is what enables your web browser to communicate with the web server that hosts a website. Most of the time, HTTP is the communication protocol you use to browse the web. HTTP stands for Hypertext Transfer Protocol. It is a protocol used while transferring web resources such as HTML documents, images, styles, and other files. HTTP is a request-response-based protocol. A web browser or client sends a HTTP request to a server, and the web server sends the HTTP response back to the browser. Next, let's explore the makeup of a HTTP request. A HTTP request consists of a method, path, version, and headers. The HTTP method describes the type of action that the client wants to perform, and it communicates it to the server. The primary or the most commonly used HTTP methods are GET, POST, PUT, and DELETE. The GET method is used to retrieve information from the given server. The POST request is used to send data to the server. The PUT method updates whatever currently exists on the web server with something else. And the DELETE method removes the resource. The path is the representation of where the resource is stored on the web server. For example, if you wanted to request an image from a page in a website, then the URL in the address bar would need to contain the full path to that particular file on the web server. There are multiple versions of the HTTP protocol. You won't explore these right now, but be aware that versions 1.1 and 2.0 are the most used. Finally, there are the headers. Headers contain additional information about the request and the client that is making the request. Headers can contain information such as the server name, the server port, the request method type, and the content type. The contents of the header can depend on the specific client and server, but these are some of the most common. And for certain request methods, the request will also contain a body of content that the client is sending. Now, let's cover some details about the makeup of a HTTP response. HTTP responses follow a format similar to the request format. Following the header, the response will optionally contain a message body consisting of the response content, such as the HTML document, the image file, and so forth. HTTP status codes contained within the header indicate if the HTTP request successfully completed. The code values are in the range of 100 to 599 and are grouped by purpose. The status message is a text representation of the status code. During your web browsing, have you ever encountered pages that display 404 error, not found, or 500 errors, server is not responding? Let's explore these HTTP status codes briefly and explain about their grouping. There are 5 groups of status codes. They are grouped by the first digit of the error number. Informational is grouped from 100 to 199. Successful responses are from 200 to 299. Redirection messages are from 300 to 399. Client error responses range from 400 to 499. And server error responses are from 500 to 599. Information responses are provisional responses sent by the server. These responses are interim before the actual response. The most common information response is 100, continue, which indicates that the web client should continue the request or ignore the response if the request is already finished. Successful responses indicate that the request was successfully processed by the web server, with the most common success response being 200 OK. You're receiving these responses every day when you receive content successfully from a website. The meaning of OK depends on the HTTP method. If the method is GET, it means that the resource was found and is included in the body of the HTTP response. If it's POST, it means the resource was successfully transmitted to the web server. And if it's PUT, the resource was successfully transmitted to the web server. Finally, if the method is DELETE, it means the resource was deleted. Redirection responses indicate to the web client that the requested resource has been moved to a different path. The most common response codes used are 301 moved permanently and 302 found. The difference between the redirection messages 301 and 302 is that 302 indicates a temporary redirection. The resource has been temporarily moved. When web browsers receive these responses, they will automatically submit the request for the resource at the new path. Client error responses indicate that the request contained bad syntax or content, or cannot be processed by the web server. Let's explore some of the most common response codes. 400 is used when the web browser or client submitted bad data to the web server. 401 is used to indicate that the user must log into an account before the request can be processed. 403 is used to indicate that the request was valid, but that the web server is refusing to process it. This is often used to indicate that a user does not have sufficient permissions to execute an action in a web application. 404 is used to indicate that the request resource was not found on the web server. Server error responses indicate that a failure occurred on the web server while trying to process the request. The most common code used is 500 internal server error, which is a generic error status indicating that the server failed to process the request. Have you ever bought something online and needed to enter your credit card information? You wouldn't want someone else to get this information from the HTTP request, right? This is where HTTPS must be used. HTTPS is the secure version of HTTP. It is used for secure communication between two computers so that nobody else can see the information being sent and received. It does this by using something called encryption. You won't cover encryption right now. Like in HTTP, the requests and responses still behave the same way and have the same content. The big difference is that before the content is sent, it is turned into a secret code. Only the other computer can turn the secret code back into its original content. If someone else was to look at the code, it wouldn't be understandable. You use HTTPS every day. This is the lock icon that you see beside the URL in your web browser. Okay, before I finish, I want to leave you with a brief summary of HTTP. Firstly, it is a protocol used by web clients and web servers. It works to transfer web resources such as HTML files and is the foundation of any data exchanges on the web. Also, remember that by using HTTPS, we send the information securely. Requests are sent by the client, usually a web browser, and the server replies with responses, which may be the return of an image or HTML page. HTTP requests have syntax that includes method, path, version, and headers. HTTP responses follow a similar format to the request, and HTTP status codes indicate whether the HTTP request successfully completed. The status code is a 3-digit number that corresponds with groups representing different types of results. Well, now you know how the HTTP protocol request and response cycle works. You know about its methods and the elements that make up a HTTP request. Good job. By now, you should know that the request-response cycle works between the client and server. In this video, you will learn how to use Django's HTTP request and response objects. Let's now explore how the request-response cycle happens inside Django. The cycle begins when the user enters a URL in their web browser. This URL is sent to the web server where Django searches for a match inside the urls.py file. Once it finds the URL, it is mapped to its associated view. Inside the view file, the view function receives the HTTP request as a request object. The view function then defines the appropriate HTTP response and sends it back as a HTTP response object. This response is processed by Django, and the client receives the HTTP response. Let's now open VS Code and explore how to work with Django's request and response objects. Open the views.py file and add the necessary imports. Next, create the view. Recall that Django uses the request and response objects to pass through the system. The APIs for the HTTP request and the HTTP response objects are specified in the Django.http module. And you use the request and response objects from this module inside the logic of the view function. Now you are ready to create the view function. Create a view function named home and pass the request object to it. Select the url.py file to ensure that the function name matches the view function inside the URL patterns list. Return to the views.py file and access the path property inside the request object by typing request.path. Now, assign this to a variable named path. It's important to note that the format needs to be changed to return the path variable in the HTTP response. The next step is to create the return statement with the HTTP response object. Inside the parenthesis, pass the path argument, followed by the content type and finally the character set. Save the file and open the localhost URL in the browser. Enter the exact location of the URL, which is main/home. Notice that the path is displayed in the main window of the browser and is the same as the order in which you pressed main and then home inside the URL patterns list. If you remove main in the URL patterns list and save the file, you can configure the URL by removing the path main. Notice that the path updates to home. This is because Django suffixed the path provided from the app level to the current path inside the project level. This example demonstrates that the HTTP response behaves like an ordinary object. Let's explore this further by creating another HTTP response object and assigning it to a variable called response. Pass the string with the message "this works." So instead of returning the HTTP response object, you can just return the variable. Go back to the browser, refresh the page, and notice the text displayed. It's important to know that this is just an example of how you can explore the HTTP response object. In a real-world scenario, developers do not usually need to modify the structure of the HTTP response object. To take this example further, you can also return the attributes of the HTTP request object. For example, you can create variables to store the scheme, method, address, user agent, and path info. You may recall that the meta tags provide information about the headers of the request object passed. One way to display the attributes of the HTTP request object in the browser window, you need to render the variables inside a formatted string in Python. Recall that to perform string formatting in Python, you use the formatted string literals. Begin a string with the character F, either in upper or lower case, and place it before the quotation marks. Python expressions are placed between the curly braces. To do this, add some HTML tags inside the formatted string and pass the variables that you created earlier. This formatted string is then stored in a variable called message. Finally, use the return statement to return the HTTP response object. Notice that the message variable is passed as the first argument. Now save the file. Refresh your URL in the browser and notice that the request object information is displayed inside the browser. A final thing to know is that you can update the header information for both the HTTP request and response objects. To do this, create a HTTP response object and then assign it to a variable called response. Next, type in response.headers and using a dictionary, add age set to a value of 20. Next, pass this value inside the formatted string. Return to the browser and refresh the page. Notice that the contents of the response header display with age added as part of the header. Developers use request and response objects when working with get and post methods. This is useful for creating forms, working with databases, and other common data structures in Django. In this video, you learned how to use the request and response objects in Django. When you access the web from your device, you may click on a web link or type in an address. The address is known as a URL, and it links or points to a specific resource or web page. In this video, you will learn what a URL is and the different parts that make up a URL. you will discover how each URL is purposefully constructed to point to a specific resource or web page on the web. Every single resource on the web is located by an address, known as the Uniform Resource Locator, or URL. Every time you click on a web link or type in a web address, you visit a URL. A URL is made up of multiple parts put together. The first part is known as the scheme. This is followed by the domain name, the file path, and parameters. Let's begin by exploring the scheme, domain name, and file path. The first part of a URL is the scheme, or otherwise referred to as the protocol. It's located at the beginning of any URL address and can be identified as HTTP or HTTPS. The characters HTTP stand for Hypertext Transfer Protocol. The protocol determines the set of rules around the transmission and exchange of data. The difference between HTTP and HTTPS is security, as the S stands for secure. HTTP sends data as plain text, which can expose the sender's information. HTTPS encrypts all data. This means the data isn't in a readable format, which is more secure. The HTTP protocol is also responsible for sending and receiving HTML across the web. HTTP and its extension, HTTPS, is the most widely used protocol over the web. Okay, so now that you have learned about the scheme, let's explore the subdomain and the domain. The subdomain is located before the domain and usually contains the home page and other important pages. The most common subdomain is World Wide Web, represented by www. It's important to know that some browsers replace the scheme and subdomain with a symbol, such as that of a lock for encrypted pages. This is done to make the URLs easier to read and understand. Next is the domain name, which consists of two parts. They are second-level domain and top-level domain. Let's explore each of these briefly now. The second-level domain name refers to an organization or the name of a company. For example, the second-level domain for the company called Little Lemon is Little Lemon. The part that follows the second-level domain and concludes your domain name is called the top-level domain. It is used to reference a country or category of your organization. For example, a .com address can indicate a commercial entity. .org means an organization, and .country code represents a country, sovereign state, or dependent territory. Now that you know what the domain name consists of, let's explore the file path. The file path, also known as the page path, directs you to the location of a resource. The resource may be any type of file that can be transmitted over HTTP, such as web documents, image files, and metadata. It's worth remembering that a URL is simply an address where the files are stored. They can either be local or web-based, which can be external to the domain. When hosting locally, the resources such as images and web files are located on the user's device or server. When web-based, they exist on the user's remote web server or external server. For example, the web-based URL for the 4.1 release for Django has its own URL with a specific file path, which includes the year, month, and day it was published. URL parameters are also known as query strings and are used to structure additional information inside a URL. You use URL parameters to capture any part of the URL and pass its value for processing. A query string is similar. It begins with a question mark symbol and is placed after the URL path. It contains parameters represented as key value pairs that can appear inside URL path. You can add more than one by adding the ampersand symbol between parameters. Django can process both types of URL, but mainly uses the URL parameters. Finally, let's briefly explore the topic of URL design. URL design is the practice of purposefully creating URLs. So, it's important for Django's developers to understand the different parts that make up a URL. This helps define well-designed URLs as the website content requirements determines how the URL will be constructed. In this video, you learned what a URL is, the different parts that make up a URL, and how they work. You now know that each URL is unique, and it points to a specific resource or page on the web. Well done! Previously, you learned that to define URLs, you first define the URL structure using the path function, and then this URL is mapped to a view function. Sometimes developers need to pass information to the view function for additional processing. In Django, developers have the option to pass values as URL parameters by using URLs as source of information. In this video, you will learn how to use URL parameters to retrieve data from a URL and send it to the view function for processing. You will also explore how to use angle brackets and path converters to capture a parameter value from the URL. Suppose the owners of Little Lemon want to add a web page to display a name from the drinks menu. The name is sent in the URL and then displayed as a heading on the page. For example, the URL can contain the names of coffees like Americano, Espresso, and Cappuccino. The last part of the URL represents a drink name, and this value can be passed to the view function from the URL as a parameter. In Django, you can capture a value from a URL using angle brackets inside the path function, where you define the URL. Captured values can optionally include something known as a converter type. You will learn more about this later. For now, just know that to capture a string, you can use the keyword str followed by name for the value. Then, inside the views.py file, you pass this name as an argument after the request object. Let's open VS Code now and create a food item page by configuring a URL and passing a parameter to the view function. First, open the urls.py file, and inside the URL patterns list, add a path. Inside the path function, define the URL as dishes/, and then inside angle brackets, place the path converter for a string. The example in this video is str:, and then dishes. Next, add the view function's location, views.menuItems. str represents the path converter type, and dish is the URL parameter name, given to match the value. For example, if the URL parameter contains the string pasta, it will be represented as dish equals pasta. Once this code is complete, open the views.py file and create the view function. First, make sure to import the HTTP response object. This function will match the path defined inside the urls.py file. In the function declaration, you need to pass an additional argument after request because an argument was passed inside the urls.py file. Inside the function body, create a dictionary called items. Once the dictionary is set up, add some entries to it. In this example, notice that 3 key value pairs were added with the keys of pasta, falafel, and cheesecake. Next, create the code to access the dictionary by passing a value and save it to a variable named description. The logic of this code is that the URL parameter value passed to this function will be matched to a key inside the dictionary. Then, the associated value is stored in the variable named description. The final step is to return the HTTP response object containing a HTML heading to display the function argument and the associated description variable as plain text. Save the code and run the server. Open the browser and add dishes/pasta at the end of the localhost URL. Remember that the word pasta is one of the dictionary items. The text displays in the browser, formatted with the URL parameter, as a heading, and the dictionary description as text. Similarly, if we modify this to, let's say, cheesecake, and press enter, notice the text updates accordingly, Defining URLs with parameters has a wide variety of uses. In this example, the logic of the view function was to pass a URL parameter that matches a description in a dictionary. Developers can also use URL parameters to send information to the logic layer for processing, or as search and sorting criteria. Similarly, URL parameters can be used to fetch data that can be used with forms, data models, and other data structures. For example, you can use a URL parameter to pass the primary key of a database table using the int path convert type. Once the primary key is sent to the view function, it can fetch the database row and its data. And you will learn how to do this later when you explore Django models. Mapping URLs with parameters is also useful to create meaningful grouping of the content. In this video, you learned how to use URL parameters to retrieve data from a URL and send it to the view function for processing. You also explored how to use angle brackets and path converters to capture a parameter value from the URL. By now, you should be familiar with the concept of mapping URLs with parameters in Django. Django lets you design URLs however you want, and you do this by using the path function and path converters. For example, creating a custom URL with dynamic values. For more complex matching requirements, you can define your own path converters using something called regular expressions. In this video, you will learn how to use regular expressions to define URL patterns in Django. Suppose you have been tasked to create a menu item page for the Little Lemon website. The page displays content for each item on the menu. Instead of making a specific page for each menu item, you can define the dynamic URL structure that will pass the menu item ID to the view function. The content of the page will depend on the menu item value passed to the view function from the URL. Based on the ID value passed in the URL, the logic in the view function will determine what type of data to display, like a menu item name. The advantage for developers is that they only need to create one page. Instead of creating individual static pages for each menu item, developers only need to create one page whose content updates dynamically based on the values passed in the URL. However, to ensure that the URL is structured in the way that the view function requires, you need a way to define and verify the values and format of the URL. To verify that the URL values passed to the view function are correct, you can use regular expressions. Regular expressions, or regex, are a set of characters that specify a pattern and are used to search for or find patterns in a string. They are a powerful tool that developers use to perform extraction and validation, advanced searching, group searches, and find and replace operations. In Django, developers use regular expressions to define, extract, and validate dynamic URL paths before they are sent to the associated view function. This video focuses on using regular expressions in Django URL paths. However, it's important to know that regular expressions are not specific to Python or Django. They have many uses across various areas of computer programming and software development. Regular expressions and their associated characters are universal, meaning they are the same across all programming languages. Let's begin by exploring an example of a URL pattern containing two entries in the urls.py file. The first path is constructed using a regular URL, and the second with a regular expression path. Let's step through the code line by line. First, you import two functions, path and regular expression path, from the Django.urls module. Regular expression path is used for paths that need to contain a regular expression. Inside the URL pattern sequence, there are two entries. This example will only explore the first argument passed inside these functions. Notice that the first path contains the URL string of menu item /10. This string is static and immutable, which means it has no possible numerical variations, even if in the same format. For example, if you enter a URL such as menu item /1, it will not match this path and map to the view. As a result, a 404 not found error message will be displayed. You can accept all URLs in this format using the regular expression path function, like in the second entry. Notice the character R at the beginning. This makes a raw string which treats the backslashes symbols as literal characters and not escape characters. Let's explore some of the most common symbols used. First is the caret symbol, used as the anchor at the start of the string. It can also be used for negation. Next is the dollar symbol, which is used as the anchor for the end of the string. You use opening and closing square brackets to define a character set that matches any one of the characters present inside. Next, opening and closing curly brackets are used to specify the exact number of preceding characters. Finally, opening and closing parentheses are used for grouping parts of the regex. Now that you are familiar with some of the characters, you can use them in regular expressions. Let's revisit the URL structure from the Little Lemon menu example. The URL begins with a string with the word menu item. Then it's followed by a /, followed by parentheses for grouping. Inside the parenthesis exists two occurrences of numbers between 0 to 9. Outside the parenthesis is another /, followed by the dollar symbol to end the string. Acceptable strings for this regex can be menu item /, followed by the range 1 to 99. Regular expressions are extremely useful while creating URLs, but at the same time, they can often get complex. And this is especially true for regular expressions containing several special characters. It's common for aspiring developers to feel confused when first learning regular expressions. Sometimes a symbol can be used for one or more purposes, or the same symbol can behave differently depending on the case. Getting familiar with their usage requires some practice and a little patience. It's advisable to start with the example in this video and build your knowledge using the remaining readings and exercises in this lesson. In this video, you learned about regular expressions and how developers use them to create and validate dynamic URLs in Django. If you would like to learn more about regular expressions, there is a link in the additional reading at the end of this lesson. An application will contain errors in some form, no matter how much testing or QA is performed. This is not always directly related to incorrect code or syntax issues. By their very nature, networks are not always 100% reliable, and things can occasionally go wrong. As an aspiring developer, you need ways to handle these potential issues. In this video, you will learn about error handling in Django. You will explore some of the most common client and server error responses that developers encounter. And you will also learn how to work with them in Django via the error handling view. By now, you should know that HTTP responses contain status codes. Recall that the 100s are used for informational, 200s refer to success, 300s for redirects or moved resources, 400s for bad requests or authorization issues, and the 500s for server issues. While this may seem like a lot of codes to learn, you generally encounter some of the same codes more frequently when working with web applications. Let's explore some of the more common client and server status codes that developers encounter, starting with client error response codes. The first is 400, which represents a bad request. This occurs when parameters passed in the request are not what the server may expect. Next is 401, which indicates that the user must log into an account before processing the request. Next is 403, indicating that the request was valid but that the web server refuses to process it. This typically means that the user calling the resource does not have the required permissions to view the resource. Finally, 404 indicates that the requested resource was not found on the web server. This typically happens when the resource cannot be located at the specified file path. Now that you know some common client error responses, let's explore some server error responses. Server error responses usually indicate a failure occurred on the web server while trying to process the request. This can mean many things. For example, the application has failed or is not running, or the time limit on the calling request may have aborted due to the server taking a long time to respond. Server error responses usually use status codes ranging from 500 to 599. The most common code you will likely encounter is the 500 internal server error, which is a generic error status indicating that the server failed to process the request. Okay, now that you have learned about the error response, let's now explore how Django handles them by raising exceptions. Django handles all error cases by raising an exception, which is invoked via an error handling view that you can configure. These error handling views are added to a separate views.py file that must be created at the project level to get applied across the project. The views to use for these cases are specified by 4 variables. They are handler 400, handler 403, handler 404, and handler 500. It's important to note that while you can use the default values and views for your projects, there may be times when you want to customize the look of these views to align with the style or theme of your site. Further customization is possible by overriding the default values. Such values can be set in the root URL configuration file of your project. It's important to know that setting these variables in any other URL configuration file will have no effect. Let's explore these variables in a little more detail now to override their defaults and implement some custom views. The first is handler 400. By default, this is the bad request view. Next is handler 403. By default, this is the permission denied view. Next is handler 404. By default, this is the page not found view. Finally, handler 500. By default, this is the server error view. As you have learned, it's also possible to implement custom views, and you will learn how to do this soon. For now, just know that to implement a custom view, the view function needs to accept the appropriate request argument and return the appropriate response. The custom views that you create using these handlers return different HTTP response subclasses that handle different types of HTTP responses. For example, class HTTP response not found acts just like HTTP response, but uses a 404 status code. Class HTTP response bad request acts just like HTTP response, but uses a 400 status code. Class HTTP response forbidden acts just like HTTP response, but uses a 403 status code. Class HTTP response server error acts just like HTTP response, but uses a 500 status code. In this video, you learned about error handling in Django. When navigating the web, it's common to occasionally enter a URL or click a link only to find that the page that you are looking for cannot be found. In this video, you will learn how to handle errors in views using Django and explore how to create a custom 404 error page using the HTTP response not found class. Recall that Django displays a page not found error page when a URL cannot be matched. This default error page displays with some technical information for the developer, including the request method and request URL. However, you usually do not want your end users to access this type of information, as these types of error messages will mean nothing to them. Instead, you can create a custom view for the error page. Let's open up VS Code and explore how to work with error pages in views and switching the debug setting from true to false. Let's begin by running a server first by typing python3 manage.py run server. Next, open the localhost URL in your browser and notice the default page loads. If you enter some URL, let's say home, notice that a page not found error page is displayed by default. The page contains some error information and a message stating you're seeing this error because you have debug equals true in the Django settings file. Change that to false, and Django will display a standard 404 page. Debugging is the process of handling errors in code. In Django, debug mode is set to true by default, which displays detailed error pages during development. To apply this change, open the settings.py file under the My Project and change the debug value to false. Additionally, you must add some value inside allowed host. In this example, add the star symbol to include all possible hosts. Save the file and refresh the web page in the browser. Notice that a different type of web page is displayed stating not found. The requested resource was not found on the server. It's also possible to create a custom view for this error page. To do this, you must create a new file called views.py at the project level. Once created, open the urls.py file and update the code with the necessary imports and URL patterns. Additionally, you must add another URL pattern outside the URL pattern sequence. Next, create the view location myproject.views.handler404 and assign it to a variable called handler404. Next, go to the views.py file inside the project folder and import HTTP response. Create a view with the name handler404, as referenced previously. Inside the function, pass the request object and an exception argument. Then return the HTTP response object with some text value such as 404:page not found. Save the file and return to the browser and refresh the page. Notice that the message is displayed on the web page. If you modify the URL with random values, the message remains the same. This is because the handler 404 handles all the pages not found by the URL configuration file. But if you add another view with a name defined in the URL configuration, notice that the view renders correctly. Similarly, just as the code uses the HTTP response object, you can also use HTTP response not found. Different classes in Django represent different status codes, and the HTTP response not found class represents status code 404 page not found. Modify the code in the function's return statement, save the file, and refresh the browser. While there is no visible change, the client receives the 404 status message internally, and you can verify this from the browser's developer tools. Inspect the element by right-clicking on the mouse, going to the Network tab, and clicking Home. Once you refresh the page and click Home again, notice 404 not found. Often developers will modify the string to add some HTML elements such as headings and a button. It's generally considered best practice to create a custom error page that's easy to understand, consistent with the website's branding, and directs users back to the home page. In this video, you learned how to handle errors in views using Django. You also explored how to create a custom 404 error page using the HTTP response not found class. Organizing your code in a clean and easy-to-use manner is essential when working on a project. As the project grows, keeping code organized and well-structured can be a challenge for developers. To help overcome these challenges, developers often use frameworks and design patterns such as MVT. For example, with the Django framework, you can use views to present data to the end users. You have already learned that you can respond to a web request in Django by creating a view function to return data using the HTTP response object. In the background, the framework passes the HTTP request to your function, expecting the HTTP response back. While this works for some use cases, developers often need a more robust solution for implementing more complicated application logic in a view. To help with this, Django provides something called a class-based view. In this video, you will learn about the concept of class-based views. You will also explore how developers can simplify their views by using object-oriented techniques, such as the concept of inheritance, to create views from inherited classes. Let's begin by exploring some of the features of class-based views. Class-based views allow you to use views as objects and offer an alternative to function-based views. Remember that a view is callable in that it can take a request and return a response. This process works great for the HTTP protocol. When dealing with HTTP, you use specific methods for the different types of requests, such as GET, POST, PUT, and DELETE. And these are the core CRUD operations for any web page. If you use a function-based view, you need to perform some conditional logic on the request method, like an if-else statement. But class-based views uses a different approach than function-based views. Instead of using conditional branching, such as if-else statements, class-based views respond to HTTP requests using class instance methods. Instance methods are default Python methods defined in classes that can access objects or instances of a class. In a class-based view, this can be simplified by adding different instance methods for the GET and POST requests. And these methods will implement the view logic independently. Class-based views respond with different class instance methods to HTTP requests in place of writing conditional branches, such as using if-else statements inside the same function. The advantage of using a class-based view in this scenario is that it allows you to remove the conditional logic to check the incoming request for the type of method. This simplifies the code and separates the logic, making it easy to understand. Another helpful aspect is the ability to have object-oriented techniques, such as mix-ins or multiple inheritance, which factor code into reusable components. In Django, you can extend the functionality of class-based views using mix-ins. Mix-ins are class-based generic views that are flexible compared to their function-based view equivalent. It can help to think of a mix-in as a form of multiple inheritance. Recall that inheritance is one of the core concepts of object-oriented design, or OOP. It allows you to derive one class from another for a hierarchy of classes with similar attributes. For example, suppose you have a class called Food. Other classes that can inherit from this class could be appetizers, entree, and desserts. They are all types of food and would share a lot of common attributes. Some common mix-ins developers use are create, list, retrieve, update, and delete. Let's explore these briefly now. Use create to create a model instance. Use list to list a query set. Use retrieve to retrieve a model instance. Use update to update a model instance. And use delete to delete a model instance. It's important to note that when using mix-ins, they can't be all used together. And in some cases, it can make your code harder to read, so it's best to use them wisely. In this video, you learned about the concept of class-based views. You also explored how developers can simplify their views by using object-oriented techniques, such as the concept of inheritance, to create views from inherited classes. Congratulations! You've reached the end of this module on views. In this module, you've learned to create views and view logic that can process basic HTTP requests, use the request and response objects for common operations, differentiate parameters and how they associate with HTTP methods such as GET, PUT, POST, and DELETE. You also learned to Exercise using regular expressions to create different URL patterns, map URLs to views, and handle errors at the HTTP, view logic, and view levels. It's now time to recap the key points. You began the module with an overview of views. Following the completion of this first lesson, you should now be able to define what a view is and know that it handles web requests and returns web responses. You know that it is just the logic that a view calls inside a method. You familiarized yourself with examples of this, such as using views to develop a dynamic website. In Django, you learned to create a view function and map it to a URL by what is known as routing, so that you can make a request response work. In addition, you can also perform either programming logic inside of view functions, such as processing data for emails and forms, retrieving data from a database, transforming data, and rendering templates. You explored the URL configuration file, urls.py, and learned why it exists. You are familiar with creating a view and mapping it to both the project and app levels with the use of VS Code. You explored the importance of using best practices through code reusability and dry principles, which are fundamental to the building blocks of Django projects. You concluded this lesson by creating a view and adding logic to handle common use cases with HTTP requests and responses. Following views, you explored requests and URLs. You started by discovering the HTTP request object and can now demonstrate how it can be used to map to URLs, map to common CRUD operations, and get information by calling the client. You delved deeper into creating more detailed requests and how to use both request and response objects for common operations. Next, you explored how URLs are constructed and how they can be mapped to a view. You unpacked URL namespacing and views, which are just how URLs can be mapped to a name and its subsequent view. You understand that the resource will point to the corresponding UI to render. Then you learned about the different options for using parameters in a web application. You can demonstrate how parameters relate to operations such as get, put, post, and delete. You can differentiate between path, query, and body params, and their association to the different HTTP methods, such as get, put, post, and delete. You also exercised setting up URL configurations using the URL dispatcher with parameters. Finally, you learned about creating URLs and views. You learned about regular expressions in URLs. You practiced how to create different URL patterns and map a URL to a view via the view function. Following on from this, you explored how to handle errors such as dealing with HTTP status responses, such as 100, 200, and 400 messages. You also discovered how to deal with error responses from the server. Furthermore, you learned to apply error handling in views when working with body requests in put and post operations. Finally, you concluded by learning more about class-based views in Django and how to reuse them across a project. Class-based views allow you to use views as objects and offer an alternative to function-based views. You also explored how developers can simplify their views by using object-oriented techniques, such as the concept of inheritance, to create views from inherited classes. You also explored different class instance methods for HTTP requests in place of writing conditional branches, such as using if-else statements inside the same function. It also removes the conditional logic, and this simplifies the code and separates the logic, making it easy to understand. You are now familiar with views and can use it to create the logic to present data to end users by processing HTTP requests and returning a HTTP response. You understand the different parameters and how they associate with HTTP methods. You can use regular expressions to create different URL patterns and map URLs to views. Throughout your development process, you are prepared to handle errors at the HTTP, view logic, and views levels. Finally, you can also use class-based views in Django and reuse them across a project. Well done. If you are building a dynamic application using a web framework, data storage using a database is essential. Recall that the presentation layer is the layer that the user interacts with. Any data posted from the presentation layer needs to be persisted and also kept for retrieval for later use. For example, if the website requires user login, it will need to keep track of who users are and what data they are entitled to view, edit, and create. The solution is to use a model, the object equivalent of a database table used in Django, and acts as a single definitive source of information about your data. In this video, you will further explore the model part of the MVT architectural pattern and learn how Django uses model classes and methods to perform CRUD operations. If you are a developer on the back end of an application, working with databases can be achieved in one of two ways. The first way is to work directly in the database to create the required tables. Then, in your application, you would need to create custom queries written in the structured query language, or SQL, to store and retrieve the data. The second way is to use a framework. You've already learned that frameworks are designed to assist developers by providing them with a platform for rapid development. And one way developers can speed up their development is by using models to interact with the database. A model is the single definitive source of information about your data. It contains the essential fields and behaviors of the data you're storing. Generally, each model maps to a single database table. Models are an integral part of the Django framework. Let's explore this structure in a little more detail now. Each model is a Python class that subclasses django.db.models.model. Each attribute of the model represents a database field. This means that instead of having to write a custom query for adding and retrieving database records, you can use a model to do it instead. Django gives you an automatically generated database access, API, to access the database with Python code. Essentially, you can think of a model as a Python object, and models help developers create, read, update, and delete objects, commonly called the CRUD operations. You will learn more about these CRUD operations in Django in just a few moments. But before you do this, let's explore a scenario to create a table called user, starting with SQL syntax and then using Django models. You may recall that to create a table in a database using SQL, you would need to write a query using the create table syntax. When the code runs, a table called user will be created with 3 columns, ID, first name, and last name. To do this using a model in Django, you define a class that will subclass the django.db.models.model. You may notice that the ID, or primary key, is not specified in the class. This is because Django automatically adds it, but you can override it if needed. At this point, it's important to know that you cannot create a database table by only defining a model class in Python. To complete this process, you need to use something called migrations, and you will learn more about how they work later. Okay, so now you know about the concept of models in Django, and that they can be used to replace SQL operations to access and manage data. Let's explore how you can use models and their associated methods to perform CRUD operations. Django automatically provides all these methods out of the box, so let's begin with create. You may recall that creating records in SQL requires you to use the insert statement. For example, to create a new user in the user table. In Django, creating records requires you to create a new object from the class user, and then persist it using the save function. Next is read. In SQL, to retrieve information, you need to write a SQL query using the select statement. For example, to retrieve a user from the user table whose ID is equal to 1. In Django, you can use the get method, which is bound to the user.objects. Next is update. Suppose you have a table of users with the user named John Jones, with the ID of 1. You want to update the user's last name to Smith. In SQL, you use the update statement to update an existing record in a database. To achieve the same result in Django, you use the methods get and save. The code works by checking if a user exists with the ID of 1 and then updates the user's last name to Smith. Finally, let's explore delete. With SQL, the delete statement is required to delete records in the database. For example, you can delete a user based on a value, such as ID equals 1. To achieve the same result with Django, you use the delete method. It's important to note that these are only some of the many methods Django provides when working with models. As an aspiring developer, it's a good idea to familiarize yourself with the ones mentioned in this video. In this video, you learned about the model part of the MVT architectural pattern and how Django uses classes and methods to perform CRUD operations when working with database tables. In the world of web application development, application requirements constantly change, and it's a developer's job to implement these changes. For example, a common task is to alter the data model of the application. And to do this, in Django, you use something called migrations. In this video, you will learn about migrations in Django and how developers use them to make changes to the models representing the database schema. Recall that Django is designed to work with a relational database management system, like PostgreSQL, MySQL, or SQLite. And in a relational database, data is organized in tables. By now, you know that you can use models to represent data tables stored in the database. Recall that when using models, Django provides many methods that allow you to add, update, and delete data right from the code without having to write SQL. This is made possible by using something called an Object Relational Mapper, or ORM. You will learn more about this later. For now, just know that it maps the relational database to objects represented as Django models. The models define the database fields which correspond to the columns in their associated database tables. For example, if you have a model called user, you know it will represent a table called user, and each attribute of the model has a column representation in the database. So, in the Python code, if the user class has an attribute of first name, the table will have a column of first name. It's common that during the life cycle of the development of the application, changes to the structure of the database or schema will be required. For example, the initial model may need to be extended with additional attributes. This means adding a new attribute which will add a new column from the perspective of the database. Or, suppose you need to perform a different operation, like changing a column name or even deleting a model. For these operations to work, Python uses something called database migrations. Migrations are how Django records changes made to models and implements these changes to the database schema. Migrations are tied into Django models and stored as migration files in a migrations folder inside each app. You will learn more about migration storage later. For now, let's explore how migrations work and return to the example of the users table. Suppose you wanted to add a new column called city to the user table. Without an ORM like the one Django provides, a developer must log into the database and run a SQL alter statement. You may recall that you can use the alter statements to alter a specific table to add a column of whatever type is required. When the statement runs, the user table updates with another column called city. In Django, the user table is created using a model which you may recall is a class-based representation of the user table in the database. So instead of writing the SQL query, you only need to add the new attribute to the model, then run the migration scripts to implement the changes. Once the migration scripts run, the changes are applied. Let's explore the process of running the migration script a little further now. Django provides a list of CLI commands that allows you to apply the migrations. First, you must create a migration script and then apply the migrations. The migration script is a set of instructions on what models to create against the database. You apply the change to the model, run the migration file, and Django will take care of the rest. You do not need to write any SQL as the application handles everything. Later in this lesson, you will learn more about running a migration script and applying it to the database. For now, let's focus on some of the reasons developers use migrations instead of SQL. You may wonder why you need migrations when it appears straightforward to just run a SQL query, like the earlier example, to update a table. Migrations do more than just implement SQL commands. They can help with syncing issues, version control, and database maintenance. It's good to think of migrations as a version control system for your database schema. Let's explore some of those benefits in more detail now, beginning with syncing issues. With migrations, you have less possibility of syncing issues between what the model has and what the database contains. When working in a team, each developer usually has their own local copy of the database, so they can code and test against it. Migration scripts are kept in the code repository. So when a developer on the team makes changes, they run the migration script to update their local copy of database to the latest version. Next is version control. All the changes are kept in version control, which provides an entire history of changes across the application. Developers can also use this to determine what changes have been added and by whom. Generally, in application development, the more you can track changes that occur in the app, the fewer problems you will encounter. The alternative is running scripts in the database directly, which is usually more problematic as it is outside version control. The last benefit of using migrations is the ease of maintenance. Along with helping syncing issues and version control, maintaining all the database changes from the codebase makes it easier for the development team. They don't have to worry about creating SQL queries directly against the database, or where to store these files so other developers can run them. In this video, you learned about migrations in Django and how developers use them to make changes to the models representing the database schema.
In this video, you will learn how to apply migrations in a Django project using the commands make migrations and migrate. You will also learn how migrations allow developers to apply version control to the models and explore the generated SQL using the command SQL migrate. I've already created a project in VS Code containing an app called My App. Inside the models.py file, I've created a class called menu items. Recall that this class is equivalent to a table in SQL and contains 3 attributes: name, course, and year with respective fields. Before I began applying migrations, I have to ensure that I have updated the model inside the settings.py file inside the project folder. When I open that file, notice that I've added the app inside the installed apps list. So I'm good to go. Okay, so back in the models.py file, the first thing I need to do is make the migration. So I run the command python manage.py and then make migrations. I press enter and Django displays a message saying that it will make migrations for my app and create a model called menu items inside it. Also, it will create a file with the name 0001_initial.py. Next, I need to apply the migration. I run the command python manage.py migrate and press enter. This time, notice that Django performs migrations with this command. Just so you're sure, let me explain the difference between these two commands. Make migrations is Django's way of preparing the changes to be made in the model. For example, it creates a database such as this one, named db.sqlite3. So you can think of make migrations as the command that generates the SQL commands and migrate as the command where those SQL commands are executed. In this video, I will not be adding any data to these tables. I only want to modify the columns inside a table by modifying the attributes in the model. Once I've run this command, notice that a folder called migrations is created inside the app folder, which consists of the file that keeps a record of the migrations. If I open the file, notice that the code contains the table columns names and an auto-assigned primary key called ID. So now you know the commands make migrations and migrate are used to perform migrations in Django. However, what if I want to make some changes to the model? For example, suppose I want to change the attribute course to category and save this file. For this change to take effect, I have to run the make migrations command again. Notice that Django displays a message that asks, was menuitem.course renamed to menuitem.category. To confirm, I type yes and press enter. Now notice that another file is created inside the migrations folder. If I open that file, notice that it contains the code changes performed in that migration. Okay, so I want to make another change to the model. So I open the models.py file again. This time I will change the attribute name to item name. So I will save the file and rerun the migration. I confirm the change by typing Y and notice that Django displays a good description of the changes I've made in addition to the new file that's created. Okay, now you know how to change the model using the make migrations command. Suppose I want to display all the migrations that I performed. To do this, I can run the command python manage.py and then show migrations. Let me expand the terminal. Notice that under the name of the app, my app, the 3 migrations I performed are displayed. The X symbol represents the commits to the migrations. Since I have not executed the migrate command for my latest changes, notice that the last placeholder is empty. So let me run the migrate command again. When I show migrations, the X appears in front of all 3 files. Now suppose that after making the changes, I want to revert back to a migration I performed earlier. I can do this by typing python manage.py migrate. Then I need to specify the name of the app and the file number, for example, 0001. But before I execute, I can add a flag such as plan. Django will then display the changes it will revert to. In this example, it'll change the attributes of menu items, item name back to name, and category back to course. This time, I execute this command without the plan flag and notice that even if the changes are not displayed in the Python file, the changes have been reflected in the database I created. Okay, so the final command I want you to know about is SQL migrate. And I can run this command against a migrated version. Notice that when I execute it, the corresponding SQL commands are displayed for the migrations I have performed. In this example, I ran it against the 3rd migration. Notice the SQL alter statement on the table named menu items to rename the column from name to item name. For Django developers, migrations are very useful as they allow us to apply version control to the models. In this video, you learned how to apply migrations in a Django project using the commands make migrations and migrate. You also learned how developers use migrations to apply version control to the models. Finally, you explored the generated SQL using the command SQL migrate.
By now you are familiar with the basics of creating a model and performing migrations. Let's build upon your understanding of models by connecting to another model using a one-to-many relationship. In this video, you will explore an example of using foreign keys as a field inside the model. In Django, foreign key is an ORM field representing a database table column. You use it to create the relationships between tables in your database. Imagine the scenario of building an online menu for the Little Lemon restaurant. The solution begins with creating a table to add the menu items for the web page. Now, Little Lemon is a restaurant that offers many cuisines, and placing each cuisine item in its correct category requires some skill. To do this successfully, start by creating another model for categories and assign the different categories to each of the menu items. Now, let's explore how to do this by using a one-to-many relationship through foreign keys in Django. Let's begin by selecting the models.py file. Here, you need to create 2 models. The first model is for the menu category, and the second model is for the menu. Later, you will add subcategories in the menu category and use the foreign key to reference these categories. It's important to know that adding both models is done the same way as adding models independently. Now, for the first model, add an attribute called menu category name and save the file. Next, create a second model called menu. Within this model, add the menu item name, price, and category ID. The next step is to assign a char field to the menu item and an integer field to the price. Let's explore where to add the foreign key. Write the models.foreignkey command in the category ID. Inside the foreign key are 2 required fields. The first field is the class for the model to connect to, and the second field is the settings that enables onDelete. So it's defined as onDelete equal to models.protect. Additionally, add another argument called default equals none. The next step includes updating the admin.py file by actioning the required imports. Next, it's time to register the models. Note that the utility becomes more evident later in the Django admin lesson. For now, ensure that the settings.py file in the app configuration is updated. Go ahead and run the server, followed by performing the migrations. Notice that the output includes two models that are migrated. Finally, run the command python3 manage.py migrate. The next step is to check the database. So, go to db.sqlite3, right-click and select Open Database. Scroll down to SQLite Explorer and select My App menu. For this example, assume that there are entries added to the database. Now, open the database again. Under My App menu categories, the ID lists 1, 2, and 3 as Italian, Greek, and Turkish. Now visit My App _menu and notice that there is a fourth field called Category ID _ID. This field has ID numbers that match the respective categories in the My App _menu table. For example, Greek salad is listed as ID 2, and in the My App _menu category, the category name is Greek. The ID of the menu is referenced and corresponds with the ID listed in the menu category. Now, let's make this more intuitive by adding another attribute called related_name equals and assign it the value labeled category _name. This means that the My App _menu now lists the category name instead of category _ID _ID. This is noticeable when running migrations again. The field category on the menu is altered. Notice that with delete.equals models.protect selected, no menu items will be removed with any category that is deleted in the category table. In this video, you learned how to implement a one-to-many relationship using foreign keys in Django models. When building web applications, developers use databases to store data and write SQL queries to fetch and manipulate that data. As applications grow in size and complexity, so too can the amount and complexity of the SQL queries. To assist developers, Django provides a feature known as Object Relational Mapping, or ORM, that automatically creates the required SQL queries. In this video, you will learn about Object Relational Mapping and how Django uses it to create SQL queries against the database. You will also explore the Query Set API and how developers use it to save and retrieve data in the database. One of the earlier challenges of object-oriented programming languages used in web development included the complexity of working with databases. Object Relational Mapping is an abstraction layer created to facilitate interaction between the programming language and databases. This allows programmers to use the SQL databases without needing to write SQL queries. A structured map is created internally by ORM that generates SQL code for a given relational database by observing the changes made to the data objects. ORM can be accessed by using the shell command. Previously, you may have noticed how each row entry added for a given model creates an object. You may recall the output had the prefix query set. A query set is a collection of such objects for a given model used in Django. And Django uses a query set to retrieve and manipulate these objects from the database. For example, suppose you have a model called customers. You can access the contents of this model by running the command customer.objects.all. This command returns the output as a query set. The list will contain the entries for the different objects corresponding to the row entries in a database. For every SQL query that can be constructed, there is a corresponding command. These commands are a part of the Query Set API. So for example, if you want to join multiple parameters using the where or limit clauses in SQL, you can use the filter function and pass the conditions to it as arguments. This will select the entry for customers who have reserved a table for 4 people. Considering the variety of complex queries that can be constructed in SQL, Django has several functions that support these operations. They can be categorized as follows, based on the required logic to run on the query set: methods that return new query sets, operators that return new query sets, and methods that do not return query sets. Let's now open VS Code and explore an example to interact with the database using these methods to return query sets. Suppose the management staff at Little Lemon wants to keep track of customers visiting the restaurant. In the models.py file, there is a model called customer that consists of attributes such as name, reservation day, and the number of seats that the customer has requested. This model has already been migrated, and the database contains some entries. To view the contents of the database, click the SQLite Explorer and select the customer table. Notice that the data is displayed. Once the database has entries, open the shell by typing python3 manage.py shell in the terminal. You may recall that once inside the shell, you first have to import the customer class from the models.py file. So type from my app.models, import customer. Now, let's explore an example of methods that do not run a query string. Let's use the customer.objects.get method. Inside the parentheses, enter an ID value such as 4. Notice that the customer name is returned corresponding to the ID of 4. This method is similar to the select statement that you use in SQL. Next, let's explore methods that return new query sets using a filter function. Suppose you want to find reservations for a Saturday. Use the method customer.objects.filter and pass the reservation day equal to Saturday. Make sure to use double quotes as you are working with a string value. Press enter and notice that the query sets for James and Jacqueline are returned. The filter method is similar to the where clause in SQL. Let's say you change the day to Friday and add another filter method with a different condition. Set the condition to seats equal 4 and press enter. Notice that only one query set is returned, and this is because that is the only query set that meets both conditions. The AND operator used is similar to the AND operator used in SQL. This operator is part of the query sets API that returns new query sets. It's important to know that the query sets API is a broad topic. If you would like to learn more about it, there is a link to an additional reading at the end of this lesson. In this video, you learned about object relational mapping and how Django uses it to create SQL queries against the database. You also explored the query set API and how developers use it to save and retrieve data in the database. Often web applications collect data from the user through a HTML form, and it's sent to the server for processing. You create a HTML form using various form elements, such as input elements, radio buttons, drop-down lists, and checkboxes. In this video, you will learn how to use form fields to store correct data types in Django. Suppose the manager of Little Lemon has asked you to build a customer form containing a customer's name and age. First, you build a HTML form that contains 3 input elements, one for the name, one for age, and one for the submit button. Previously, you learned that Django creates and processes forms using the form class. This class defines all the expected attributes that will construct and process the form. Once you lay out the structure of the form fields are the building blocks that help build the form. While fields are an integral part of models, they are especially important while using forms, as they help define the visual element of the form. The custom logic behind the fields is defined in the fields class used inside the form class in Django. When defining attributes, you can choose from various field types. Let's explore some of these briefly now. First is char field, which accepts any string input and is equivalent to the text input element in HTML. Next is email field, which accepts input that follows email format. It's equivalent to the email input element in HTML. Integer field accepts only integers and is equivalent to the number type input element in HTML. Multiple choice field offers the choice of multiple options. It's equivalent to the select and option elements in HTML. Finally, file field allows you to choose a file for upload and is equivalent to the file type input element in HTML. Additionally, these form fields have different arguments that can be passed to them. While specific arguments that can be passed vary according to the field in use, there are a few core arguments that are accepted in common among all the fields. These are required, label, initial, and help text. Let's explore each of them now in a little more detail. Required. Each field assumes the value is required by default. You can change this by setting required equal to false. Label. The argument helps specify a label for the field. Initial. Initial values can be set for specific fields. Help text. Specify descriptive text for the field. It's important to remember that every form that you build will have different data requirements. For example, a customer feedback form or a survey-style form for a customer's favorite menu items. Knowing what field type to use is essential to building effective forms. Let's open VS Code now and explore the different fields that can be used to create a form and the customization options available. The Django project is set up with a file called forms.py created. And notice that the file imports the forms package. Now let's begin by creating a form and exploring the different form fields available with it. First, you create a demo form that will contain a car field. Let's explore this form in the browser and notice that Django creates the label name in the form. This name comes from the value of the attribute that is defined. If you change this, it will update on the form. You can edit the form further by passing a parameter such as a widget with the value forms.textArea. This text area will override the default widget for it, which is the equivalent of rendering the input field present in HTML code. If you refresh the page again, notice the form is updated. Okay, so the code works, but suppose you want a smaller text area to display. You can pass a parameter inside the text area, such as attributes with a certain number of rows. Apply this update, save the file, and refresh the browser. Notice that the text area is smaller, with space for 5 rows. Next, let's explore the email form field. Replace this code with email equal to forms.email field and save the file. Refresh the page and notice the form updates with an input for the email form field. It's also important to note that Django form fields have basic validation applied by default. For example, suppose I enter an invalid email address and try to submit the form. Notice that an error is displayed, stating that you must enter a valid email address. If you add a valid email address and press the Submit button again, notice that the form does not display an error. To help the user know what to add in each form field, you can use the label parameter. For example, add a label parameter with the text to enter an email address. Save the code and refresh the page. Notice that the label now displays in the form and replaces the default attribute value. Let's now explore another example, using the date field. Inside the code, you can use a widget called numberInput that requires additional input from forms.widget. Suppose you want the customer to enter a date in the date field for a reservation date at Little Lemon. If you save the file and refresh the page, notice that the reservation date displays. You can click on it to open a calendar and select a specific date. One last example that you can explore is the choice field. This example uses a constant to be passed as a parameter inside the choice field. The values saved in the constant allow customers to select their favorite dish at Little Lemon. Once again, save the file and refresh the page in the browser. Notice that there is a drop-down menu for the choices. However, suppose you want to display all three choices simultaneously. You can achieve this by using another widget option with the value of radio select. Save and refresh and notice that the choices are now visible as radio buttons that the user can select. It's important to note that these examples showcase just some of the available form fields and parameters you can use in Django. Exploring the Django documentation for all available options to help you create forms is a good idea. And you can do this from the link in the additional reading at the end of this lesson. In this video, you learned how to use form fields to store correct data types in Django.
By now, you should be familiar with the concept that developers use the form class to automatically generate HTML for form elements from classes. In this video, you will learn how to create a form using the form class in Django. You will also learn how to render a form using a template. Finally, you'll explore some of Django's form features such as validation. Let's begin creating the form. First, I need to create a file called forms.py inside the app directory. In this scenario, I will create a form on the Little Lemon website that allows the employees to log their entry times of work. In this video, I will be only demonstrating how to build the form using the Forms API in Django. You'll learn how to process forms in Django later in this course. The process of building forms in Django is very similar to creating models. First, I use the import statement to import forms from the Django module. Next, I create a class called inputForm, which will hold the form and pass it forms.form. This class needs 4 attributes. The first 2 attributes are first name and last name, which will be character fields with a max length set to 200. The third attribute is shift, which will be a choice field. It will let employees choose between morning, afternoon, and evening shifts for their work. Inside the choice field, I pass the choices as one constant called shifts. Then at the top of the code, I assign the value of this constant to an iterable of tuples inside a tuple. I need to add one final attribute called timeLog. This attribute will log the entry time for a given employee. So I type forms.timeField. Okay, my code looks good, and that's all I require for creating a form. Let me now switch to the views.py file, and just like I did with models, I need to create a view for this form. I do this with the import statement to import the form from the app directory. Okay, now I'm ready to create a view. First, I create a view function called formView. Next, I create an instance of a form and pass it to a variable called form. Then I create another variable called context, which is assigned to a dictionary with form as the key and the instance object of inputForm as its value. Finally, I pass this variable inside of the render function, which will display the output of an HTML page called home.html. But for this to work, I must build a web page by creating a template. So I first create a templates folder inside the app. Next, I create a home.html file and paste the HTML code inside of it. It's important to remember to use the form method of post as I'm sending the data from the form and creating an object from it. I've also included a submit button represented by an input field with type and value set to submit. To finish this form code, I have to add something called a CSRF token, which is simply a way of telling Django that the form data is safe. Finally, I pass the form that I've created. Okay, so my code looks good. Let me save all my files. And before I continue, I ensure I update the urls.py file both inside the app and the project folder. I also need to update the settings.py file with the reference for the app. I'm now ready to run the server. In the terminal, I type the command python manage.py run server. I navigate to the localhost URL and enter the path for the form. Success! The form displays on the web page with the form elements first name, last name, shift, and timeLog. You may notice that the form does not have any styling applied. While I could use some CSS, I'm not going to just yet. Instead, I want to demonstrate a trick to structure the form elements using paragraph tags. So back in the file home.html, I can modify how the form is rendered by amending the form to form.as_p. This will tell Django to render the form elements as paragraph tags. So I'll save this file again and refresh the web page. Notice that the form elements all appear one after another. When I press the Submit button, notice that Django also provides basic form validation where all of the elements are required. If I want to change this, I can pass a parameter inside the forms file. For each attribute, I can type required equals false. So I save the file again and refresh the web page. I press Submit and notice that the field first name is not required at this time. Similarly, I can pass other parameters. For example, inside the time log, I can type help text equals and then the text enter the exact time. Once again, I save and refresh and notice the text is displayed beside the time log field. Finally, I can open my HTML file to add some inline styling to the form. Inside the form declaration, I add a background color. I save the file one more time and refresh it. Notice that the form displays with the background color. Working with forms can be complex, so developers can use Django's form functionality to simplify and automate vast portions of this work. By creating forms this way, developers are guaranteed to add Django's layer of security. It was not possible to demonstrate how to process and save the form in this video, but I hope you're thinking that maybe Django offers similar functionality to process and save forms as it does with creating them. And if you're thinking that, you're correct, and you will learn how to do this soon. In this video, you learned how to create a form using the form class in Django. You also learned how to render a form using a template. Finally, you explored some of Django's form features such as validation.
So far in the course, you have learned how to create models as well as forms using class implementations by Django. But what if you want to use them together to save entries entered in a form inside a database? Django provides a very efficient way to do that using model form by providing a means to save received data as a response directly to the database. In this video, you will learn how to use model form. The process of creating such a model form is similar to that of creating a model and form. Just like in the case of model and form, Django provides another helper class called model form that helps in an easier implementation. Let's take an example. Say you want to create a reservation form for the Little Lemon restaurant. In the example, you first import the model you want to bind with your form. Then you add implementation details for it using a meta class. And finally, you create an instance of that form. Note that instead of having separate classes for form and model, you have just one that inherits the model form and implements it. Since this is an implementation that involves sending form data back as a response, you also need to add some implementation details about the post method inside the view. Let's now examine how you can implement this. Previously, you learned that you can use the Forms API to generate a static form using Django. Just as a reminder, notice the code in the forms.py file and how it is used to render a form in the browser. Building on the project that's already in place, let's modify the form to use model form this time. So, first to simplify, remove the shifts attributes. And since this is a model form, copy the contents and paste it inside the models.py file. Next, you need to reconfigure all the details so that it matches the configuration code for a model. Notice how the class name changed from logform to logger, which is the name of the model. Next, let's go to forms.py again. Delete the existing content and then create the model form based on the model that is in place. So first, import the model using from.models import logger, which is the name of my model. Then type class logform, which is the name for the model form. And this time, pass model form inside it. Next, add class meta, followed by the name of the model, logger, and another attribute called fields. And instead of assigning individual fields, let's just enter the value of all, which will import all the fields inside that particular model. Let's save this file. Next, you must make sure that you register the model. For this, go to admin.py and update the details. Next, switch to the views.py file. Once inside the view, notice that there is already some basic configuration that helps render the form. If you recall, the form object which this time is the model form, is passed inside a context dictionary, which is then passed inside the render function. Now, you must add some code that will help accept the form data and send it to the model database. So, let's add a conditional statement such as if request.method equal to post. Next, add form equal to log form, and then pass a request.post inside it. What this code does is update the form object with the contents of post inside the request object. Next, check if the form is valid, and if so, save the form using the save method. Let's save this file. You already have everything you need in terms of the form template. After you run the migrations, run the server. Go to the browser again and refresh it. Next, enter the name Kyle McGregor and the time 11 minutes past 11. And once you press the Submit button, notice that the post method is logged on the console. In the left panel, you can go to the database, right-click on it, and click on Open Database. Inside SQLite Explorer, once you expand it, click on My App_Logger. This is the name of the table created from the model. Click on it, and notice that the entry has been updated inside the database. You can add as many entries as you like, and every time the entry will be added inside the database. This is an example of how the model form can be used to create a form and save the form data to a corresponding database table. In this video, you learned how to create a model form. Well done. When you develop a web application, much of the content is stored somewhere, like in a database. As a result, a common task is to provide an administration or admin site as part of the application. The purpose of this admin site is to allow certain users to administer and manage the data of the application. In this video, you will learn how to activate Django's admin interface and how to use its core feature. You may remember this when you covered the topic where the path configurations for the admin were set by default inside the URL configuration files. Now, suppose the owners of Little Lemon have asked you to store all of the website content in a database so it can be updated by the restaurant staff. For example, managers can use the admin site to add or edit content, and that content is displayed on the public site. For developers, building such a site for each project can be tedious work. Django solves the problem by automatically creating a unified admin interface for site administrators to add, edit, and delete content such as users, permissions, and database entries. This process is automated as the admin interface directly links to the models in the project once registered. The admin interface is usually a part of a large web application to help the administrator perform certain administrative tasks. The tasks, such as creating and managing users, controlling access permission, and forming user groups. Django reads the models declared in the project and, from the metadata of models declared in a project, it quickly builds an easy-to-use interface. It's important to remember that the admin site isn't intended to be used by site visitors. It's for site managers. In addition to the interface, another powerful feature of Django is that it provides a ready-to-use admin interface named Django Admin. And as you have already learned, you use this command line utility for administrative tasks. The Django Admin utility is executed from inside the terminal. It is enabled and assigned to a project by default when you run a command such as start project inside Django. As the admin interface depends on django.contrib.admin app, you'll find it in the installed apps section of the settings.py file, along with certain other apps. Databases are an inherent part of building a web application. Using Django and Django Admin provides a convenient means of accessing and modifying these databases from a friendly user interface. Before you access this interface, you first need to create an admin user that provides you with the necessary credentials. Let's explore how to do that now and have an overview of the Django admin interface. First, you must create a user. So, for that, run the command python3 manage.py. Then, add the keyword create superuser. Next, in the username prompt, you must create a username. So, for example, add John and press enter. Notice that if a user is already created, Django will throw an error stating that the username is already taken. Now I create a user called Adrian and press enter. Next, another prompt appears for the email address. Let's type adrian@littlelemon.com and press enter. Then enter a password and press enter. Notice that because this is not a strong password, Django displays a warning stating that the password should be more secure. You can ignore this for now and press Y, which stands for yes. This will let us continue, but it's important to know that in a real-world application, the password should be strong and meet security requirements. Once you create the superuser, run the command to run the server, and open the default URL in the browser. Next, go to the assigned path and add /admin to the URL and press enter. Notice that the Django administration page loads with the login form where you are prompted to enter a username and password. So, type the username and password that you created earlier and click the Login button. After logging in, notice that there is a basic interface. The first option gives an overview of the groups and users. There is already a sample model named reservations, and below that there is a list of recent actions which are empty at the moment. You have an option to add and change these configurations. If, let's say you go to the reservations model and click Change, notice that there are a few entries listed. You have an option to directly update the reservations data using the form or add new entries. You can also delete the selected reservation by clicking the checkbox next to the names. If you go back to the main page, there are other options to add or modify the users that already exist. For example, if you click a specific user, you can change the username and password, the personal info, and also assign the user to some groups. Additionally, you can designate specific permissions that the user can have, which will be listed below. There are also other additional details, such as last login information and the date of joining for the user. You can also go to the top of the page and check the history of the user and the changes they have made. The utility of this might not be immediately evident, but as you proceed in the course, you will realize how using the Django admin panel can save a lot of time for the developer by providing an interface that is easy to modify inside your project and model. In this video, you learned how to start Django's admin interface site. You also learned how it can be used to add users, groups, models, and assign permissions, which you will learn more about later. Good job!
In this video, you will learn how to create a basic reservation system for the front desk of Little Lemon. You will explore how to use the admin.py file to register a model and add users and groups using Django administration. Employees at Little Lemon have been manually entering reservation details on a sheet. However, they want a more efficient way to do it. First, let me open the models.py file, which contains a model, and notice it's already populated with some code. It contains a reservation class with 5 attributes. The attributes consist of the name of the customer, their contact details, and the time of their arrival. The final 2 attributes will be to count the number of guests and for some additional notes. Next, I need to open the settings.py file and ensure that the app is added to the installed apps list. Everything looks good, so I just need to make the migrations, and I'm ready to create the reservation system. The first thing I need to do is to create a super user. I do this using the command python manage.py create super user. I enter a username such as Meta, and again enter an email address such as admin@littlelemon.com. I will use a weak password for this demonstration, but it's important to know that you should always use a strong password in production. Notice that Django sends a prompt for password validation. I type Y and the super user is created successfully. One final thing I need to do before running the server is register this super user. Okay, so now I'm ready to work in the admin.py file. First, I import the reservation model using the import statement. On a new line, I type admin.site.register and inside the parentheses, the name of the table reservation. Now I can save this file and run the server. In the browser, I open Django at the default URL and add /admin to it. I press enter and notice that a new page loads with a login form containing username and password fields. So I enter the credentials I set up earlier and click on the login button. The default Django administration page loads containing two sections, Site Administration and My App. In Site Administration, notice there are links for groups and users. Then, in the My App section, notice a link for the reservations table I created earlier. If I click the link, notice that there are no reservations added, and this means that the table is empty. So let me first create some reservations. I click on the Add Reservation button, and now an Add Reservation form displays. I enter some details such as name and phone number. For the time input, I can click on the word now to get the current time and then modify its format. I will set the reservation count to 4 people. And finally, I will add a note such as we would prefer an outdoor table. I want to add another reservation, so I click on the Save and Add Another button. Notice that a success message displays and the form has been reset, so let me add another reservation quickly now. I add the name Charlotte and a phone number and time. I will set the reservation count to 2 people, and for the notes, I will type a message like, we would like a seat by the window. Okay, so I'm finished with adding the data and I can just click on the Save button. Once I save, notice that 2 entries have been created, which are displayed as reservation objects. However, this does not display much information about the reservations, so let me fix this. Back in the models.py file, I can use the str method to override the default string representation of the object and define my own. I want this representation to be the name of the customer. So using the return statement, I type self.name, which will display the value stored in the name attribute of the object. I save this file and then go back to the browser and refresh the web page. Notice that the name of the reservation objects have now been renamed according to the customer. If I click on the customer name, the web form will load where I can edit the details if I want to. There are also options to delete the object and explore the version history. Now let me navigate to the app. Notice I have options to add a new table or change the current one. Okay, now let's explore the users and groups of Django administration. I click on the home link, and first let's explore users. Notice that there is just one user, which I added earlier. I can add another user by clicking on the Add User button. I type Little Lemon Staff and the username input and add a password. Notice that if I try and add a weak password, Django will not let me. So let me add a password that's a bit stronger. I click the Save button and notice that the user has been added. Once created, I can add personal info for the user, such as first name, last name, and email address. In the permissions section, I assign permissions such as active staff and super user. Recall that users with the permission of staff can access the admin page. It's also possible to add users to groups, but it's beyond the scope of this video. You will learn how to do this later. I can also set some permissions. For example, I select that this user can only view and change the log entry. To the right, notice that these are the added user permissions. Finally, details for the last login and date joined are displayed in the important dates section. Let me save this, and once I go to the users page again, notice that the staff Little Lemon user with the name of Jean was added. I can filter users according to super user status. So if I select this option, notice that only the meta super user is displayed. I can also create groups by selecting the groups link and clicking on the Add Group button. On the Add Group page, I can assign the name of the group, such as staff. Then I can set the permissions for the staff member and save them. And this allows me to configure which Little Lemon staff can access the admin panel and make the reservations. Finally, I can preview the table in VS Code using the SQLite Explorer. If I click on My App, then Reservations, and then Show Table, notice that these entries are updated in the table. So once I make the changes in Django administration, they're reflected in the table. In this video, you learned how to create a basic reservation system for the front desk of Little Lemon. You explored how to use the admin.py file to register a model and add users and groups using Django administration.
You may remember that you can create different types of users in Django. Now, You will explore how to add and remove permissions for these users. The Django framework has a built-in mechanism that manages permissions quite efficiently. The Django admin web interface makes it easier for you to create and modify users or user groups. You can also grant or revoke permissions for individuals and user groups. While Django admin has a user-friendly interface, which makes handling permissions quite easy, it is also possible to handle permissions through the Django shell. To demonstrate this, let's first create a user, and then locate the required user by its username. To do this, you must first open the interactive Django shell that has Django settings already imported. It allows you to directly work with the root project folder. Next, import the user module from the specific django.contrib package. Then define a variable and assign it the createUser method, and pass the arguments for username, email, and password in that order. Once the user is created, define another variable and assign it the get method of the user object. Then pass the username as the argument. Once the user is created, the next step is to assign permissions. Django comes with a built-in permissions system. It provides a way to assign permissions to specific users and groups of users. When django.contrib.auth is listed in your installed apps setting, it will ensure that 4 default permissions are available. This functionality allows you to add, change, delete, and view permissions, and are created for each Django model, defined in one of your installed applications. Permissions can be set not only per type of object, but also per specific object instance. By using the methods provided by the model admin class, it is possible to customize permissions for different object instances of the same type. Similar to the admin permissions you learned about, permissions specific to models can also be managed using the model admin class. The model admin class methods include view, add, change, and delete, and are used to customize the permissions. Now that you have learned about the concept of permission using the Django shell, next let's explore user objects. User objects have 2 main fields, known as groups and user permissions. User permissions store and reference a single or multiple permission objects. Permissions can be granted or removed by calling the methods set, add, remove, and clear on the user object. Let's explore an example using the add method to grant permissions to the user Mario. In this scenario, let's provide 1 or more permission objects. You use the add method to add a permission to change the menu model inside the app My App. It's important to know that once you add django.contrib.auth to the installed apps list, you must run the migrate command to implement the change. Note that when you run manage.py migrate, each Django model is assigned the default permissions. For example, suppose you have a Django app called My App, in which there is a model named My Model. If you run Boolean expression to verify the permissions to add, change, delete, and view, they will return true. In addition to the default permissions, custom permissions can be declared in the model's meta class, which can be declared inside the model. So far, you have covered how you can modify permissions on the Django shell. However, in practice, it is much easier to deal with them using the Django admin interface in the browser. Let's explore how you can add and remove permissions using the Django admin interface. Building on the earlier example of adding groups and users, let's explore how to assign permissions to different users using the Django admin panel. In the browser at the admin login page, let's enter the credentials for the existing super user. Once you log into the admin panel, notice that you have choices for groups and users. In the authentication and authorization section, click on the link for groups. The first thing to know is that you can create groups in addition to the existing staff group. For example, let's say you want to add some more groups. The first is for the reservation desk staff, and the second is for the Little Lemon website administrators. Click on the Add Group button, and a new page with a form to add a group loads. You must give the group a name. In this example, the name will be Reservation Desk. Inside the Permissions section, notice that you have several options in the Available Permissions table. Let's say you want to assign this group permissions for the reservations model. You can select the reservation permissions to add, change, delete, or view reservations. Then, click the Choose button to add the permissions to the chosen permissions table. Once transferred, click the Save and Add Another button to create the group for the website administrators. Notice that the Add Group form resets, allowing you to add another group. Create a new group called Admin Users, but this time assign all the permissions by clicking the Choose All button. As all the groups are created, you can click the Save button. OK, so now that the groups are created, the next step is to add the users. In the Authentication and Authorization section, click the Users link to open the Users page. Suppose you want to create a user called Mario inside this section. Remember, Mario is the owner of Little Lemon. Click the Add User button to load a new web page that displays an Add User form. To add a new user, you must enter the login credentials. So, enter Mario as the username, and then set a password. Click the Save and Add Another button to add a new user. The second user is Meher, a staff member at Little Lemon. Assign a password and click the Save button. Notice that when you click the Save button, Django Administration immediately takes you to the page where you can assign additional information to the user you just created. There is a Personal Info section where you can add the user's first name, last name, and email address. In the Permissions section, you can change the permission level and assign the user to a group. In this example, the user Meher is a staff member, so let's keep the permission as active and also assign the permission of staff status. Next, assign Meher to be part of the reservation desk group. It's important to know that once you assign a user to a specific group, all the permissions that are entitled to the group get automatically assigned to the user. And it's also possible to assign additional user permissions. When you finish assigning a group and permissions to a user, press the Save button. Next, it's time to add a group and permissions to the user Mario by clicking on the user's name in the Users table. First, enter the personal info for the user Mario. Next, assign him the status of Super User. Make him a part of the admin group and save the changes to return to the users page. It's also possible to filter the users by different categories. In the Filter panel, you can filter by the staff status, super user status, or the status of the groups in which they are assigned, such as admin users. Finally, on the main home page, notice your recent actions display in the Recent Actions section. This feature allows you to configure different users quickly and set their permission levels. In this video, you had an introduction of how to handle user permissions from the Django shell. You also covered a demonstration of how to add groups, users, and modify permissions using the Django admin interface. Good work. When creating a Django project, the default configuration uses an SQLite database. It is automatically set inside the file settings.py file. This means that you can directly start working with the database immediately. SQLite is known as a user-friendly zero-configuration database, and there are many advantages to using it. You don't need to install anything to support the database, as it doesn't run as a server process. This means the database does not need to be started are stopped or require additional configuration files. As a result, this type of database is suitable for small projects or rapid prototyping. Suppose you are developing projects that need a quick test environment. In that case, SQLite is a solid option as it doesn't require running a separate server. There may be occasions when a more scalable, robust database is needed. For example, when moving from a development to a production environment. In this video, you will learn how to configure database options to work with a MySQL database in a Django project. Django supports the use of many databases with minimal configuration. These include PostgreSQL, MariaDB, MySQL, Oracle, and SQLite. Among these, PostgreSQL and MySQL are most commonly used. Django has features to support each database that make it easy to connect and work with. It provides a generic way to access the different types of databases, and a connection to a database is established by knowing the type of database. Within this lesson, you will deal with one of the most popular and widely used databases, MySQL. Let's begin by exploring how to set up database connections to a MySQL database. To connect to a MySQL database, you need to provide the address where the database is running, the port number, and the database name you wish to connect to. You also need a database driver, which is responsible for mapping all the models and translating Python queries into SQL instructions via the model. To use MySQL, the driver or connector MySQL client needs to be installed. When you connect to a database, the connection opens on each request and is kept open for a specific time. The connection is controlled by the conMaxAge parameter and represents a certain time before the connection is automatically closed. To establish a connection, you must configure parameters under the Databases option of the settings.py file. By default, the configuration is for SQLite. You can also use an options file for MySQL to store the database connection credentials, and you will learn about it later in this lesson. The credentials can include the database name, username, and password, and are stored in a separate configuration file. Inside the file settings.py, the MySQL connection reference looks for the connection file in the directory etc/MySQL. And notice that this is not within the Django project. This is a deliberate security measure. Okay, now that you know the steps needed to connect to a MySQL database, let's explore database creation. While Django creates all the tables based on the models you have from the migration scripts, the initial setup requires you to manually create the database. Creating a database requires a connection to the database itself and sufficient permissions for authentication and authorization. It's important to remember that you must keep the database secure by assigning security roles and using strong usernames and passwords. The data stored may contain end users' personal information, so keeping it private and safe is of the utmost importance. As a developer, you need to be aware of potential security risks, and one significant risk is the security of the credentials of your database. Allowing someone to know or access the username and password of your database can have major consequences. The database connection credentials are only accessible on the virtual machine or server where the web application is running. In this video, you learned how to configure database options to work with a MySQL database in a Django project. Django is so popular because it's open source, with a rich set of tools that allow for easy scalability and rapid development. MySQL is one of the many databases which Django supports. Recall that databases help store data from different sources that can be used for different purposes, such as adding content to a web page. The Django development framework has internal support for connecting with different databases. Previously, you learned that Django uses something called an Object Relational Mapper, or ORM, and ORM facilitates the mapping of data between databases and the application model without the need to write any SQL queries. MySQL is a popular database management system and can be used with Django when there is a heavy data load. Let's quickly recap some of the features of MySQL. It's open source and well documented. It's reliable and quick, as data storage is done efficiently in memory. It's scalable and can work with small to vast amounts of data. Finally, it's secure and provides a layer of security with encrypted password protection that is flexible and verification-based. It's important to know that before you begin working with models, you need to have a database installed. Django provides the SQLite database by default, and no pre-installation is required. However, if you want to use another database, you must install and configure it. Let's now explore the steps to install and configure MySQL within a Django project. Before you can begin using MySQL with Django, ensure that MySQL is installed on your computer. Depending on the operating system in use, you can use the different site packages that are available on the MySQL website. The examples in this video refer to Mac OS. You can find commands specific to other operating systems from the additional reading at the end of this lesson. For Mac OS, you can use a package manager, such as Homebrew, to manage your installation. Begin by typing the command brew install MySQL. This installs the MySQL database. Next, go into MySQL to access the databases. Note that there are specific commands when using Mac OS. Now type the command mysql-u root-p. -u refers to the username, whereas root-p is the password. Now press Enter to action a password request. Notice that the password entered here matches the password set for the root inside the MySQL database. Inside the shell, go ahead and type the command show databases and end your query with a semicolon. This generates a list of all the MySQL databases on your MySQL server. For example, create a database called feedback. To do this, type the command create database feedback semicolon. Now run the show databases command again, and now your list includes the new feedback database you've just created. The next step is to create a user for the Django project. Okay, so run a command labeled create user 'admin Django identified by password semicolon. The password is the word password. Note that there may be variations to this particular command, but this is one of the simplified versions. Now press Enter. Next, you enter the command to grant permissions to the user. The final command here is flush privileges. Now, the database is ready to use. The next step is to install a database connector. This is used to allow the MySQL database to interact with the Django ORM. In this example, you'll use MySQL Client Library. There are alternative options you can use, such as any of the Python 3 database connector libraries that are compatible with Django. For now, exit the MySQL shell and type the command pip3 install MySQL client. Note that you may need to install extra files that allow this specific library to work on this operating system. Once the database and the database connector are in place, go to the settings.py file inside the My Project folder. Here, Django will reference information about the database connection. To use MySQL, the database needs to be in a specific format. Replace the database code with that of the settings for MySQL, and replace the database name with feedback. It's important to note that in this example, the database name is feedback. Always check the name of the database that you want to connect to. Next, replace the user with admin Django, and the password with password. The final step before you can use the database is to run the migrations. So let's run the following two commands. First, type the query python3 manage.py make migrations and press Enter. Next, type python3 manage.py migrate. Notice the list of migrations you've just performed. However, your view of this is limited because there are no entries inside the database. In the absence of using MySQL database for the majority of the course, it is always good to know that there are alternatives available to the SQLite database, and these are installed by default inside Django. In this video, you learned how to set up a MySQL database connection in Django. Congratulations! You've reached the end of this module on models. In this module, you've learned to create models, apply migrations to appropriate use cases using best practice principles, and learned to use the QuerySet API to interact with the database. Next, you discovered how to create a form and use the form API to bind data to objects. You learned how to use the Django admin panel to add and control the permissions of users and groups. And finally, unpacked how to set up a MySQL database for your Django app. It's now time to recap the key points and the skills you've gained. You began the module with models and migrations. Here, you explored models, fields, attributes, and keys. You are now able to describe the relationship and similarities between models and databases with tables, and demonstrate how to create models in Django, focusing on the different attributes. Furthermore, you can now summarize the concept of migrations and how they are beneficial in web applications through best practices dealing with issues and rolling back. You can discuss how migrations can save a lot of time for development teams by separating the SQL away from the coding. There is no need to create SQL queries directly against the database, or where to store these files so that other developers can run them. Next, you explored Object Relational Mapping, or ORM, and how Django uses it to create SQL queries against the database. You also discovered the QuerySet API and how developers use it to save and retrieve data in the database. Following models and migrations, you learned about models and forms. You were introduced to Django's rich framework for forms and how to manipulate form data to extract and send information. You are now able to showcase setting up a model with different data types and how they are mapped from a standard body request. You also exercised creating forms by using the Form API and some of its inbuilt data types. Next, you focused on admin. This section introduced you to the Django admin and some of its core features. You can demonstrate how to create and manage users and groups directly from the admin panel to provide access to the web applications. You also learned how permissions work at the view, model, and controller levels, and how they can be added using the Django admin view. Lastly, you can set up users and add or revoke permissions. Finally, you explored database configuration. You are now able to showcase the different database options that are available in Django, with MySQLite and MySQL as the main focus. You practiced the steps needed to set up the database configuration, an SQLite database for local development. Then you learned about the configuration options for setting up a MySQL database and exercised setting up a MySQL database connection and testing that it's up and running. You're now familiar with models. More specifically, you can create models and apply migrations. You can also use the QuerySet API to interact with the database and create forms by leveraging the Form API to bind data to objects. You familiarized yourself with the Django admin panel to add and control the permissions of users and groups. Finally, you concluded by setting up a MySQL database for your Django app. Well done! You're making excellent progress through your Django development. Web frameworks often need to generate dynamic content to render on web pages, and because Django is a web framework, it provides a convenient way to generate HTML dynamically. Dynamic content is any data that changes according to context, user behavior, and preferences. Developers can use dynamic content and rendering to produce static HTML code. The most common approach for developers is to use templates. In this video, you will learn how to use templates in Django. You will also explore the concept of the Django template engine and the Django template language. Templates are text-based documents, or Python strings marked up using the Django template language, or DTL for short. Templates consist mainly of two types of content, The first is static. This is the HTML that does not change on the web page. The second is template language. This is the syntax that allows you to insert dynamic data. Let's explore an example of creating a HTML heading element using dynamic content. In this example, the variables dish name and price are placed within the double curly braces. These variables represent dynamic content. The remaining content, including the HTML heading tags, is static. It's important to understand that the static part defines the structure and layout of the page, and a view using the render function handles the processing of the dynamic content. You may recall that the render function takes 3 parameters: request, path, and a dictionary of variables. When you pass the dictionary object to the render function, the process of rendering replaces variables present with their values, which are looked up in the context. While you use template language to render dynamic content, the concept of a template is what makes up the presentation layer of the MVT architecture. This helps in the separation of logic because templates handle the user interface logic of a web page. It's important to know that the dynamic content inside the static HTML is written so Django can understand the syntax and formatting. Python is a dynamic object-oriented programming language, while HTML is a static markup language. To bridge this gap, Django makes use of the Django Template engine, and the Django Template language, or DTL, is the language used for adding dynamic content. DTL can contain embedded dynamic content, such as Python code and variables, that the template engine processes. DTL consists of constructs such as variables, tags, filters, and comments. Each construct has a specific syntax that helps Django understand the code logic. For example, you can use tags and comments to build a for loop to display list item elements. The tags map the dictionary values from the context and helps to add logic to the template. You will learn more about each of these later in the lesson. Additionally, Django also provides an API for loading and rendering templates. You define the configuration settings for the template engine inside settings.py under the project directory. It's important to know that the app directory setting must be set to true. This setting tells Django where to search for templates. For example, search inside a subdirectory named templates for each application in the project. You can also add specific locations inside the directory setting for Django to search for directories inside the DIRs option. In addition to the Django template engine provided by Django, you can also extend the functionality by using one or more template engines. For example, Jinja 2 is a popular template engine used in Python, and you can configure the settings for adding these extensions inside the settings.py file. For example, you can change the default environment settings for Django to use Jinja 2. Okay, so now you know about template engines. Let's explore the concept of code reuse. Django helps in code reuse by using templates with the help of something called template inheritance. Template inheritance allows developers to build a base template containing the expected HTML elements of your site and defines blocks that child templates can override. Once defined, all pages of the website can inherit the base template. This code reusability helps in saving developers time and effort and follows the principle of dry. For example, you can create a base template containing the HTML code for your site's head, body, and main sections. Then, in a child web page, you inherit the base template and place the specific content of the page. It's a standard best practice to place template files inside a template folder. In this video, you learned how to use templates in Django. You also explored the concept of the Django template engine and the Django template language. Templates are quite a vast topic in Django, and you will learn more about them for the remainder of this lesson. Web page design can become time-consuming, especially if you work with dynamic web pages. When building a web application in Django, templates provide developers with many benefits. One of the main benefits is that they promote code reusability and render dynamic content. In this video, you will learn how to create a template using Django Templates and the Django template language. You will explore the steps to render static HTML elements that display dynamic content from a Python dictionary. As you have learned previously, in Django, developers use templates to display dynamic data. Let us now explore this in a little more detail. The view functions retrieve the data from some data structure or database connected to our application. Developers use templates and the Django template language to display this dynamic data. Templates contain static HTML and dynamic data rendered by the render function. The render function takes three parameters: request, path, and a dictionary of variables. Let's explore this in a little more detail now. Request represents the initial HTTP request object. Path represents the relative path of the HTML file to the template directory or folder. And the dictionary contains the variables as keys that the template can use to display dynamic data. Okay, so now you know about the structure of the render function. Let's explore how it returns data to the user. The render function returns a string as part of the HTTP response object that the web page renders. Since this process is created inherently with Python code, there is flexibility to define and pass variables to the template. To create a template inside Django, you can take the following steps. First, you define a view that returns the render function. Next, update the URL configurations inside URL patterns. Then, ensure that you configure the settings for templates and installed apps. Next, create a HTML page containing static HTML and dynamic data using the Django template language. Finally, make sure you pass the name of the template page and dictionary as arguments inside the render function. Now that you know about the process of rendering a template, let's open VS Code and explore the steps further. In this example, let me demonstrate how to create a template that returns HTML content using a dictionary for the About page of Little Lemon. To begin, create a view inside the views.py file. For this example, let's create an About page for the Little Lemon website. The first step is to create a view function called About and pass the request object inside it. Next, return a render function and pass the request object followed by the HTML page named about.html, which will display the content. The next step is to ensure that the URL configuration files are updated in the urls.py files at both the project and app levels. Okay, so the code looks good. Now, go to the settings.py file and add templates inside the DIRS key. Then, you need to make sure that the app is registered. Next, you need to create the about.html page. So, go to the main project directory and create a folder called Templates. Now, right-click on the Templates folder and create a file named about.html. Notice that within the about.html file, by typing an exclamation mark and selecting the first option, VS Code will automatically create the code for a basic HTML page. Inside the body tag, add the heading element h2 with the text About. Save the file and run the server by typing python3 manage.py run server and press Enter. Launch the browser at the localhost URL and add About at the end. Notice that the template is rendered from the content you created in the about.html file. Okay, so now the template is working. Let's use it to create some dynamic content. To do this, first go to the views.py file and create a dictionary called About Content. Next, create a key value pair named About and : followed by a string containing additional content about the Little Lemon website. Now, save the file. The next step is to pass the dictionary inside the render function to give the template access to the dictionary object. Now, once again, save the file. Next, go back to the about.html file. Then, add a paragraph tag with the keyword about inside double curly braces. This is the key inside the dictionary object. Now, save the file, go to the browser again, and refresh the page. Notice that the page updates and the additional content is displayed. Now, if you modify content inside the dictionary, save it and refresh the page again, notice that the content is automatically updated. Finally, you can add some styling, such as a background color, to your HTML. Save the file and refresh the web page. The page now reflects the styling updates. This example demonstrates how to create a HTML template in Django with some static content inside a heading and some dynamic content inside a paragraph. In this video, you learned how to create a template using Django Templates and the Django template language. A common requirement when creating web applications is the need to add dynamic data inside HTML markup. This data can be represented by a variable containing dynamic or calculated values, or values stored in the database of the application. Either way, a web framework needs a way to understand this data. To address this, Django uses Django Template Language, or DTL, to separate the presentation and application logic. In this video, you will learn how to work with the Django Template Language. As you learned earlier, a Django template is a Python string or text document marked up using Django Template Language and interpreted by the template engine. The DTL is based on the popular Jinja 2 template engine and has most of the features common to it. As a developer, writing code in a familiar language is beneficial. DTL helps remove that barrier by providing flexibility that aligns with the core time-saving principle in Django of do not repeat yourself, or dry. It also adds a layer of security, as the Python interpreter does not execute the template code. Once you understand the use of template languages, much of the logic in creating the templates becomes evident. There are four main constructs in the syntax of DTL. They are variables, tags, filters, and comments. Combined, they provide the substitute for basic functionalities present in a programming language. Let's explore each one now in a little more detail, starting with variables. Variables are surrounded by double curly braces. When the template engine encounters a variable, it evaluates that variable and replaces it with the result. Variables return a dictionary-like object that maps keys to values. In this example, restaurant name is the key with the value of Little Lemon. When rendered, this template code displays Welcome to Little Lemon Restaurant. Similarly, you can use dictionary attribute and list index lookup using dot notation. Okay, now you know about variables. Let's move on to tags. Tags are the source of logic that you can add to templates. Tags are created using curly braces and the percentage symbol. The most commonly used tags are the control structures such as if and for loops. The if tag is used inside the template to render different outputs. A typical use case is to check the login status of a user. The code in this example checks if the value of the Boolean variable logged in is true or false. If true, the page renders the welcome statement. If false, it renders the login link. Another standard workflow is to iterate over the dictionary to display an unordered list. To do this using a template, you need to have some way of looping over the data and printing out the HTML markup with the data object for each item in the list. Let's now understand how a template list with a for loop works. For example, suppose you have a simple list that contains menu items for the restaurant. Each item has a name and a price. To create this menu statically, you wrap each menu item in an unordered list using the list item tag. To create this menu dynamically with templates, you add the for loop code, where items repeat. In this menu example, it's inside the unordered list. The code will iterate over the menu list object and display the name and price. The variable item will keep a reference to each object as the iteration continues to go through each menu item. Apart from if and for, there are many other tags such as extends and include, and you will learn about them later in this lesson. Now, let's explore filters. Unlike tags, filters can change the values of the variables. For example, if you add a filter such as string upper, it will take an input string and convert it to uppercase. Filters can also additionally take an argument, like when using the date filter. For example, you can pass the argument for year, month, and day, which produces a date in this exact format. Finally, let's explore comments. You can create comments using the curly brace and percentage symbols. Django ignores everything in between the two tags. It's important to note that developers use comments for documentation as they do not render. In this video, you learned how to use the Django template language. Developers frequently use tags and filters when working with DTL to create dynamic data. And you can learn more about them from the link in the additional reading at the end of this lesson.
In this video, you will learn how to use templates to return a web page with dynamic data to display a menu for Little Lemon. You will explore how to create templates and use them to get data from a dictionary and display it on a web page. You will also learn to display data using a for loop with a dictionary inside a template. First, I open my app's views.py file. Next, I create a view function that takes the request object as a parameter. I create a dictionary inside the function by adding open and close curly braces. Then I define name as the key and give it the value of Greek salad. I now need to assign the dictionary to a variable, which I'll call menu item. Okay, so the code for the dictionary is complete, but this time, instead of returning an HTTP response, I will use the render function. So inside the parentheses of the render function, I pass 3 parameters. First, the request object, and then the name of the HTML file, and finally the variable that holds the dictionary. It's helpful to think that a Python dictionary is similar to a JSON object commonly used in web development. So my code is set up to work with the template file menu.html, so I need to create this now. Back in the project directory, I create a new folder called templates, and inside it create a new file called menu.html. I open this file, and now I want to write the code to dynamically display the dictionary object. To do this, I start by creating double curly braces, and inside them I pass the key of the dictionary, which in this example is name. I then save the file. To ensure that Django finds the menu.html file, I need to open the settings file and add the name of the templates folder inside the templates list. I also need to make sure that I have registered the app in the installed apps list. The final step I need to perform is to open the urls.py file, and inside the URL patterns list, I add the path function. I then pass the URL I want to map to, so I type menu / and then the name of the view function to be called, and this is views.menu. Okay, so I'm happy with my code. Let me run the server and open the URL in the browser. I navigate to the menu page and notice that the value stored in the dictionary is displayed in the browser. It's important to know that the values held in the dictionary are the content that will display on the web page. And this is the logic I created in the code by passing the dictionary key in the HTML template. And this is an example of returning dynamic content to a web page. If the value in the dictionary updates, so will the value displayed on the web page. And I can add as many key value pairs inside the dictionary as I want to. I can even wrap this content inside HTML tags, and you'll learn more about this soon. By now you know that in Django, developers can use templates to make a static page dynamic. The layout of the page can be structured with HTML, and the dynamic data is then placed inside the double curly braces. The double curly braces imply the dynamic content, and it's something that is called Django's template language. Let me expand on this concept a little more now. Back in the views.py file, I will replace the dictionary with an object containing some more values. This is a little more complex. Notice that mains is the key and then a list of dictionaries, is the value. Inside each dictionary are two key value pairs with name and price as the keys. Notice that I have assigned this to a variable called newMenu, which is passed inside the render function. So to display this in the browser, I will have to update the code and logic in the menu.html file. Inside menu.html, I remove the existing code. Next, inside a set of single curly braces with the double percentage symbols, I need to loop over each item in the dictionary using a for loop. So I type for and then item in mains, which is the dictionary's name. Next, inside a set of double curly braces, I type item.name and then add item.price. Finally, I need to close the for loop. Okay, so my code looks good. I save the file and then open the browser and refresh the page. Notice that the items from the dictionary are displayed. While the code works, I want each menu item to be displayed on a new line. To do this, I can add some HTML. So back in menu.html, I paste some HTML table tags with inline styling applied. Now when I refresh the page, notice that the menu displays inside a table. So now I should be able to add another dictionary and the content will update on the web page. Back in the views.py file, I add another item, hummus, with a price of 5. I save the file and refresh the page. Notice that the values are updated dynamically on the web page. This is how you can create programming logic and apply it to templates to render dynamic data on a web page using Django. In these examples, I demonstrated the rendering of dynamic data using a dictionary as the data source. It's important to know that this data source can be other things like a database or an API, and you'll learn how to do that soon. In this video, you learned how to return a web page with dynamic data using templates. One of the reasons Django is so popular is that it allows developers to create dynamic website content quickly. With just a few steps, you can take data that's stored in a database, write some logic for it, and then display it to the end user in the browser. Previously, you learned how to display dynamic data on a web page using objects that were passed to a template. In this video, you will learn how to create a dynamic menu for Little Lemon by passing a model object to a template from a view. You will also explore how to loop over an object and display its content using a for loop with the Django template language. So I'm in VS Code, and I have the models.py file open. Previously, you learned how to create a model named menu with attributes for name and price. Notice that name is set to a char field and the price to an integer field. I've also created a dunder string method that will render a string for the objects with the name attribute. And recall that this just helps with visualization and identification in Django administration. If I open Django administration in the browser, recall that this model contains data like the menu items for hummus, falafel, and so on. Okay, so my code is now set up and I'm ready to create the view function. Inside the views.py file, I create another view function called menu by ID. And just like in earlier videos, I pass in the request object, but there are a couple of different steps I need to take. First, I import the menu from the models.py file. Next, inside the function, I need to create an object containing all the values present inside the menu model. To do this, I use the method menu.objects.all and assign this to a variable named newMenu. The next step is to create a dictionary using similar logic represented in the code above that you learned about previously. So inside the curly braces, I create a key called menu. And the value will be the variable newMenu. And this will be assigned to another variable called newMenu_dict. The last step is to return a render function that takes 3 parameters: the request object, the name of the template file, and the dictionary. There's a lot of code on the screen, so let me just comment out the view function I created earlier. This will also ensure no regular expression conflicts as some of the names in the two functions are similar. I save this file and now I need to check the mapping in the urls.py file. Notice that the URL inside the path is set to menu_card as the URL resource location. For the final part, I need to create an HTML file with the same name that I typed inside the render function, menucard.html. Inside the file, I pass the menu key from the dictionary. Okay, so let me check that I've saved all my files. I open the browser and navigate to the URL menu_card and press enter. Notice that the query set object is displayed on the web page. I want the page to only display the items of the object, so I need to modify my code. So back in the HTML file, I need to use the Django template language with a conditional statement. I start by adding single curly braces with a percentage symbol. Next, I create an if condition by typing if menu to check if items are inside the menu. If this condition is true, I use a for loop to iterate over the items in the menu. On the following line, I add item.name and item.price. Then I need to make sure I end the for loop by typing end for. Finally, I will add one more piece of logic, an else condition, that displays some text if the menu object is empty. I end the if condition, and my code looks good. So I save the file and refresh the web page in the browser. Notice that only the object's names and prices are now dynamically displayed. It's important to understand that this data was taken from a database and stored in a model object using the model. Then I looped over the object to display each value for name and price. My code is working, but I can take this further by adding one final step to wrap the dynamic output with HTML paragraph tags. If I save the file and refresh the web page, notice that each item now displays on a new line. Finally, to demonstrate this dynamic web page text, let me add another item to the database using Django administration. I add the item baklava with a price of 10. I save the item and switch to the menu page and refresh. Notice that the content updates automatically and displays the new item. In this video, you learned how to create a dynamic menu by passing a model object to a template from a view. You also explored how to loop over an object and display its contents using a for loop with a Django template language.
When developing web applications in Django, recall the key principle of don't repeat yourself, or dry. Duplication, whether inadvertently or purposeful, can lead to maintenance issues and logical contradictions. Every distinct concept or piece of data should live in one and only one place. The framework within reason should deduce as much as possible from as little as possible. For example, to create the same header and footer sections across multiple pages for the Little Lemon website, you can make a copy of the markup and save it multiple times. Then, only change the corresponding title for each web page. But a more efficient method is to build a base template containing all the common elements of the website and assign them to a block. This block can then be repeated on every web page. In this video, you will learn about template inheritance in Django and how developers use it to speed up user interface development. Suppose you have the task of creating a prototype for the new Little Lemon website. The website has 4 pages for Home, About, Menu, and Book. So far, only one prototype page exists, and this is for the About Us page. In order to work with templates efficiently, it helps to break the page up into sections. And in Django, these sections are referred to as blocks. For example, at the very top of most websites, you find what is called the header, and this is the first section or block. The header often contains the company name and logo. It also usually has links to the different pages of the website, which is known as the navigation menu. Additionally, the header might contain a section where users can log in. This usually includes a user icon, along with a drop-down menu with a link to the user profile. When working with the page layout, it's best practice to keep the look of the header consistent and in the same position across all the pages of a website. This consistency is essential for a good user interface and contributes to a positive user experience. Because if the header is visible on all pages of your website, it makes it faster and easier for the user to navigate. The same can be said for the footer. The footer is a section at the bottom of a web page that contains essential company or contact details, navigation links, and copyright information. At this point, you may be wondering, how do I incorporate the header and footer across the 4 pages for the Little Lemon website? That's where you use template inheritance. Template inheritance allows you to split out content by breaking it down into individual components. You can then insert and reuse these components without duplicating work. And this saves you a lot of time. Remember, dry is a key principle in Django, and template inheritance is a great example of this. Okay, so now you are familiar with the concept of template inheritance. Let's explore the two tag options needed to apply it. They are the include and the extends tag. Let's begin with the include tag. The HTML markup on the base page now references the files containing the code for the header and footer sections using the include tag. If you need to make an update to either of these files, you'll only need to do it once and not on every page. The include tag lets you either specify a template string or a variable to allow conditions for different rendering. For example, say you want to pass an object which contains information such as the page name. To do this, you can pass a dictionary as an argument inside the render function to pass variables or objects to the template. To gain access to specific data from the header file, such as the page object, you need to add additional attributes inside the include tag. Once added, you can access the page object anywhere on the page. For example, to display the page name as a heading element. It's important to remember that this object is part of the dictionary that was passed inside the render function inside the view. Let's recap. When using the include tag, you instruct the page to render this subtemplate and include the HTML. This means that there is no shared state between included templates. Each include is an independent rendering process. Okay, let's move on to the second tag, which is the extends tag. This is similar to the include tag with syntax and usage. However, its purpose and functionality differ. Extend allows you to replace blocks or content from a parent template, as opposed to include that will include parts. Extend creates a parent-child relationship, where parents' functionality can be overwritten. Include, on the other hand, simply includes rendering a template in the current context. There are two ways to use the extends tag. The first is that it can use the string literal as the name of the parent template to be extended. The second is it can make use of the value of a variable. Once the variable evaluates to a string, Django will use that string as the name of the parent template. For example, say you have a file called header.html that contains code for a navigation menu represented as an unordered list. You can extend the file contents of header.html to a file called about.html. The code will effectively add the contents of header.html to the content inside about.html. In this video, you learned about how template inheritance can save you time by reusing blocks of content such as headers and footers. Well done! You should have the 4 little lemon pages developed in no time. Up until now, you've discovered what template inheritance is and explored the include and extends tags in Django. Remember, the extends tag allows you to replace blocks or content from a parent template. It creates a parent-child relationship where the child can overwrite the parent's functionality. Likewise, the include tag adds parts and includes the rendering of a template in the current content. It is easy to get confused between extends and include, but there are differences that will become clearer with practice. Let's begin with a demonstration. Suppose that you must design the Little Lemon website that contains 3 pages called Home, Menu, and About. While the contents of each of these pages will differ, there are a few basic styling components that need to be uniform across the website. Additionally, you may want the menu bar as part of the header so that it can be present on all pages. Let's explore how to use the extends and include tags to implement template inheritance in Django. Let's begin with the views.py file. You need to set up 3 views, namely Home, About, and Menu. These are the 3 pages you are creating for the Little Lemon website. Ensure that you update your URL configuration file both at the project and app levels. Also, map the respective URLs to the views. Next, update the settings.py file by adding the app inside installed apps. Then create a template folder as part of DIRS in templates. To work with templates, you need to create a folder called Templates by right-clicking on the My Project folder and selecting New Folder. When working with template inheritance, you need to create another folder in My Project called Partials. This is where you will include the header information. Now let's continue by creating a base.html file inside the templates folder, which will contain the code for the base HTML that you want inside all other pages of the website. Still inside the partials folder, create the 3 pages for the Little Lemon website: About, Index, and Menu. Also, create a file called _header.html in the partials folder. This is the file that you will use inside the include tag in the base HTML file. Now that you have the file structure set up, let's begin by adding some code to the base HTML file. Remember that you can just type exclamation mark and press Enter to add the basic HTML stub. Next, update the title tag to Little Lemon. Also, add a main tag inside the body tag. Here, you need to add the tags for the block content. This allows you to use it with the extends tag. So, type block content inside the first set of curly braces and close it off by typing end block in the second set of curly braces. Make this block content stand out by adding some styling with a background color inside the body tag. Now save the file. The next step is to edit one of the pages. Let's edit index.html. Add block content and add 2 paragraph tags inside the block content tags. Now to utilize template inheritance, add the extend tag at the top of the index.html file by typing extends open quotation mark base.html close quotation mark. For this example, go ahead and apply the same steps to add content to the other web pages. Remember to save the file and run the development server by typing python3 manage.py run server in the terminal. Type home in the URL and press Enter. Success! It is clear that the template has rendered to the home page. Why? Remember, you did not add any specifications for a background color in the index file. What happens here is that the background that you specified in your base HTML file is extended from the base.html file. Well done! You just used template inheritance. Similarly, if you go to the About page, notice how the details have changed according to the information present on this page. In summary, the base.html template renders on each of the pages, but the unique content of each page displays in the block content. Now, let's add header information using the include tag. You need to add content to the header file and save it. To carry this through consistently to all the web pages, go to the base.html file and add an include tag that contains the header file reference. Save the file again and return to the server. Once the web page is refreshed, notice the header information at the top of the page. This will be displayed across each web page without affecting the rest of the page information. This is much more effective than adding the header file inside a specific page, which will render the header information only on that single page. In this video, you learned how to use the include and extends tags to utilize template inheritance in Django. This skill will save you a lot of time in your future web development projects. Debugging is the process of identifying and isolating an error, finding the source, and deploying measures to solve the problem. While making mistakes is a part of programming, correcting errors inside a web framework such as Django can be particularly difficult. Unlike errors occurring in a standalone file that can be easily spotted, web projects consist of several interlinked files and dependencies that can make troubleshooting challenging. While debugging takes patience, it also helps build a better understanding of the internal working of an application. In this video, you will learn more about debugging Django applications. Mistakes can happen in many forms and at any stage of the development process. These can include missing adding a view, creating incorrect templates, missing import statements, inaccessible resources such as model data, or even missing a comma in some attributes passed inside a function. As a beginner, seeing the errors and having to troubleshoot can be intimidating. While observation and hands-on practice with web applications are the best means to overcome errors in Django projects, there are tools available that can speed up the process of getting a project up and running. You already know how to raise a few errors using provided internal implementations, but there are unforeseen errors that occur that also need to be attended to. Django has a distinct debugger that appears in the form of a yellow page error. You may recall seeing the debug equals true flag on the home page of the local host after running the server. The Django debugger is enabled by default and settings, for it can be found and modified inside the settings.py file of your project. While it is a useful component of development, the developers of Django recommend that it should never be used in the production environment. This is because it may expose internal file paths, as well as database and project configuration details to the end user using your website. This can be prevented by changing the setting to debug equals false. Other than the default debugger provided by Django, Django, as you know, is written in Python and can easily integrate third-party libraries that help in debugging. Let's now examine a few ways in which you can debug Django applications. This example uses the Creating Forms project demonstrated earlier. Begin by launching the development server. Immediately, you'll notice there is a 404 page not found error, and this is because you haven't configured the URL for the local host. Also, notice that this displays in the console in the logger. It's important to know that the default Django implementation enlists all the steps that Django has performed after you run the command. Let's now go to the correct URL. Notice that the logs update at the bottom inside the console. Now open the forms.py file. Python-specific errors will most likely occur in the console log. For example, if you comment out the shifts constant and save the file, notice an error log displays inside the console. The name error displays with the text, "Name shifts is not defined." And if you try to refresh the localhost URL in the browser, notice that the page will not load. However, some other errors are not that obvious. For example, remove the import you passed inside the log form and save the file. Notice that you do not get any error in the log. However, if you refresh the web page, notice that the template for the form disappears except for the Submit button that was rendered using static HTML markup. To prevent this from happening, always ensure you have the right imports and that you pass the correct arguments inside functions. Let's say you open the file mytemplate_home.html. Inside the file, remove the code for the CSRF token and save the file. If you go to the localhost URL and reload the page, notice that the forms render correctly. Fill out the form and press the Submit button. Notice that an error displays stating "Forbidden CSRF, verification failed." This error specifies that the CSRF token is missing, which is helpful for troubleshooting. So, you can broadly say the yellow page errors are more specific to problems inside Django than Python code. Now let's say you go to the files.py file again and misconfigure the template you are trying to render. So let's say you call this home_page.html and save it again. Once you go to a template page, you get an error such as template does not exist in the particular path. Let's examine this page in a little more detail. First, it specifies the exception location, and you can get a hint from Get Template and how it is raised during Form View. Next, if you keep scrolling, you get a stack, which is called the traceback stack. It contains Python code in sequential order, with a particular line highlighted, which will likely be the place of the error. You can also convert this to switch to copy and paste view. When you change this, you get a much cleaner interface mentioning all the details. You can additionally click on Share this traceback on a public website, which, when clicked, will take you to dbase.com. This page displays convenient clipboard content that you can share on different forums. If you scroll down further, there's information about the dictionary containing all available HTTP header information called meta. On further scrolling, you can find details inside the settings, and all of these are potentially helpful. Regarding debugging, you can never apply a one-rule-for-all approach. With practice, the number of errors you encounter will slowly decrease. And a systematic and patient approach in dealing with these projects is the best way forward. In this video, you learned how to debug Django applications, which will help you in the future when you have to troubleshoot errors. Testing is an important component in the software development lifecycle. While debugging is more driven towards removing the application's errors and bugs, testing considers metrics for quality, reliability, and performance. It effectively saves a lot of time for the developer. Every language and framework has many testing options, and developers make appropriate selections based on the project's requirements. Many testing packages and tools work well with Django. A popular method is unit testing, which you can use to isolate a function, class, or method and only test that piece of code. When working with unit testing, you need the following baseline information. First, the test targets granular features in your code, the smallest possible testable units. Then the output of the test will be pass, fail, or an error. In this video, you will learn the concept of testing in Django using an example of the unit test module in Python. In Django, the unit test module uses a class-based approach. You add the tests inside a class that inherits a class called testCase from the Django test package. Suppose you wrote a model called reservation and want to test it. First, import the testCase class that inherits testCase. Then import the reservation model. Once you create the tests, use the command python3 manage.py test. Additionally, you can add specific configurations to run all tests within a specific package. For example, run the command python3 manage.py test reservations. To run a specific test case, use the command python3 manage.py test reservations.tests.reservation test case. Or, suppose you want to run a specific test method inside a test case. For example, a method to calculate the seat count. You can run the command like python3 manage.py test reservations.tests.reservation test case.test seat count. It's important to know that developers generally add these test cases under one or more files created under specific app folders. In a small project, it's common for developers to name the file tests.py. In large projects that may contain multiple test files, it's common for developers to use names like testmodels.py and testviews.py. Okay, now you know about the concept of testing in Django. Let's open VS Code and explore an example to create a unit test. Earlier, you learned how to use unit tests in Python to test code. In this example, you will explore how Django uses the unit test module with the test case package. Let's explore how you can test the model data inside a Django application using a test case. Notice that the project is already created, and the app configuration is set up inside the settings file installed apps list. In this example, you will work with two files, models.py and tests.py. Inside models.py, you create a model and add the test code inside the tests.py file. If either of these files does not exist, you can create them inside the myapp directory. So first, you add a model inside the models.py file. This model will record the first name, last name, and the booking time for a reservation a customer makes at the Little Lemon website. The Auto Now field inside the booking time logs the system's current time and is set to true. Next, save the file and go to tests.py. Notice that the test case module inside the Django.test package has already been imported. Additionally, you must import the required package called datetime. You also must import the model that you must use, which is the reservation model. The next step is to create a class called reservation model test and, inside it, pass the test case. Next, you add a setupTestData class method and pass a class object inside it. setupTestData is a method present inside the test case that you use to add data inside the model. So, in this example, data is entered for the first name and the last name. It is important to know that booking time automatically updates as the AutoNow parameter is set to true. Next, you create a function called asTestFields to check if the first name and the last name that are received are in a string format. You perform the check using the assert statements to check both the first name and last name are of the string data type. Similarly, you must create another function called asTest_timestamps. Inside this function, you insert another assert statement, such as assert instance, and this time compare the booking time to the imported date time. Okay, once this code is ready, you must run the migrations since you have a newly created model. The final part of this step is to remember to add the class method decorator, since this is a class method. Now save the file. With this code complete, you are now ready to run the tests by typing python3 manage.py test in the terminal. Press enter and notice that the application ran and passed 2 tests. The running of the tests is represented by the 2 dots displayed in the terminal. Back in the model, let's change one of the fields from string to int to see if the test produces a different result. So save the file and run the test one more time. Notice that one of the tests has failed. Additionally, an assertion error is displayed, stating that the last name you have assigned is not an instance of an integer class. The assertion error is also indicated by the characters f dot, which means that one of the tests has failed and the other one has passed. If you are familiar with using unit tests in Python, notice that the implementation is similar to that which you will find in conventional Python code. This example demonstrated how to implement a basic test in Django. Django as a platform and framework is pretty huge. So it's important to remember that many testing configurations and options are available to be explored by the developer. In this video, you learned about the concept of testing in Django using an example of the unit test module in Python. Congratulations! You've reached the end of this module on templates. In this module, you've learned to create templates and use the template language to create markup and templates to generate HTML. You also explored troubleshooting through the processes of debugging and testing. It's now time to recap the key points. You began the module by exploring templates. Now that you've completed this first lesson, you can express what templates are in Django and how they benefit you when using logic to create HTML structures. You were introduced to the Django template language, or DTL for short, which consists of constructs such as variables, tags, filters, and comments. Then, you practiced how to create templates to render static HTML elements that displayed dynamic content. Following the first lesson, you learned about working with templates. More specifically, you explored working with template language and variable interpolation. You are now able to create dynamic templates in Django and map model objects to the template. Next, you explored template inheritance, where you split out content into individual components and reused these segments across HTML pages such as headers and footers. Using dry principles ensures that you don't duplicate work. You learned that template inheritance used two main tags. The first is the include tag, which renders a template. The second is the extends tag, which makes use of a string literal and a value of a variable. This just allows you to replace blocks or content from a parent template. Finally, you learned about debugging and testing. Here, you learned about debugging Django applications. Django has a distinct debugger that appears in the form of a yellow page error. Recall the debugger equals true flag. The Django debugger is enabled by default and settings, for it can be found and modified inside the settings.py file of your project. This default error page displays some technical information for the developer, and you do not want your end users to access this type of information. This can be prevented by changing the setting to debugger equals false. Mistakes can happen in many forms and at any stage of the development process. These can include missing adding a view, creating incorrect templates, missing import statements, inaccessible resources such as model data, or even missing a comma in some attributes passed inside a function. You also learned that debugging is more driven towards removing the application's errors and bugs, and testing considers metrics for quality, reliability, and performance. It effectively saves a lot of time for the developer. You know that every language and framework have many testing options that work well in Django. A popular method is unit testing, which you can use to isolate a function, class, or method and only test that piece of code. In Django, the unit test module uses a class-based approach, where you can add the tests inside a class that inherits a class called test case from the Django test package. You have reached the end of this module and are now familiar with templates. You can create templates and use templating to generate HTML. You can work with templates and integrate third-party libraries into your Django app. You can also use class-based views in Django and reuse them across a project. Well done. In this course, you learned about the principles of the Django framework. Let's take a few moments to recap the key topics that you learned about. In the opening lesson, you covered an introduction to the Django framework. During this introduction, you learned how developers use the dry principles to organize code. You explored the use of the MVT framework to ensure reusability of code. Then you learned how to create an app inside an existing Django project using the correct structure. Next, you learned to use some of the basic commands with Django admin and manage.py. And finally, differentiate between an app and the project structure. You then moved on to explore the view part of the MVT framework. In this topic, you learned how to create views and view logic that can process basic HTTP requests. Then, you learned about URL configuration and how to map URLs to views. You also examined the use of the request and response objects for common operations. After that, you learned how to use regular expressions to create different URL patterns. Then, you learned how to differentiate parameters and how they associate with HTTP methods such as get, put, post, and delete. Finally, you explored how to handle errors at the HTTP, view logic, and view levels. You then progressed to learn about the model part of the MVT framework. In this topic, you learned how to create models. Then you learned about the concept of migrations and how to apply them using a best practice approach. You also examined how to use the QuerySet API to interact with the database. After that, you learned how to create a form and use the form API to bind data to objects. Then you learned how to use the Django admin panel to add and control the permissions of users and groups. Finally, you explored how to set up a MySQL database for your Django app. Next, you moved on to explore the template part of the MVT framework. Here, you learned how to work with templates and use templating to generate HTML. You also learned how to create templates and use the Django template language to create markup. Finally, you expanded on this knowledge to create rich templates using template inheritance. Are you confident that you have mastered these skills from this course? If the answer is yes, you are now ready to put in practice what you learned. For the graded courses assessment, you are required to create the menu pages for the Little Lemon website. It's time to demonstrate your skills and showcase what you learned in the course. Good luck. The first step is to open the models.py file and update the menu model with the description attribute. Next, in the terminal, run the commands to perform migrations to implement the changes to the models. Once this is complete, log in to Django admin using the super user credentials created earlier and update the menu items with the description provided in the zip file. Inside the Django admin panel, click the menu model from the restaurant app to display the list of menu items. Select a specific item from the list to edit and update the description with the details provided in the zip file. Once all the descriptions are added, open the views.py file and create a view function called display menu item. The function must contain two arguments, request and the primary key, set to the value of none. Inside the function body, add the code to define the view logic. Use the if condition to check if the primary key contains a value. If true, create a variable menu item and assign it the value of the primary key of the menu model using the objects.get method. For the else condition, assign an empty string to the variable menu item. Return the render function from the view and pass the following arguments: the request object, the template name menu.html, and a dictionary object with the string value menu item as the key, and a variable menu item as its value. Once this is complete, open the app-level urls.py file and add the path function inside the URL patterns list. Before you configure the new menu item page, open the file menu.html and update the code to add the link to the menu item page. Select the complete string inside the href attribute and replace it with the detailed code for the dynamic link for the menu item page. Remember, do not remove the enclosing quotes for the string of the HTML attribute. The next step is to create a file called menuitem.html inside the templates inside the app called restaurant. Once created, add the starter code. Replace the code matching the comment using the appropriate Django template language syntax. To begin, add the name attribute from the menu item object. Next, add the description attribute from the menu item object. Then, add the price attribute from the menu item object. Finally, add the code to display the image that is stored with the menu item name. While you are adding these steps, ensure the changes are inside the enclosing paragraph tags. Now it's time to save the menuitem.html file and make sure all the other file changes are saved. Next, add the command to run the server. Paste the localhost URL to the browser and add the file path of menu at the end. Press Enter, and the same page displayed earlier should load, but this time the menu item name displays as a hyperlink. Click on the link Greek salad, and the menu item page for Greek salad appears. Notice that this page only contains the information that is stored in the database row for Greek salad and displays the name, description, price, and image. Now it's time to move to the third part of the project and create the footer. Congratulations on completing the graded assessment, one of your final steps to test your skills and understanding of the Django framework. Let's walk through the solution. The first part is to create the menu page. Open the file models.py and create a model classes for the menu. Make sure to define a dunder method inside the model class, so the name will be visible in Django admin. The next step is to open the admin.py file and register both models. It's important to ensure that both models are imported from the models.py file. Now that the models are in place, run the commands make and perform migrations. Once the migrations are completed, open the project level and app level URLs.py files to ensure the URL path configurations are in place. OK. The next step is to add content inside the models you created using the Django admin panel. First, create a super user by running the command in the command prompt with the following details: username, bistro admin, email, admin@littlelemon.com, and password, lemon@786! Once the super user is created, add the command to run the development server. Open the browser with the browser preview button and paste the localhost URL generated in the terminal. Add the admin path to the URL to access the admin login page. Enter the credentials for the super user you created and log in to the Django admin panel. Inside the Django admin panel, locate the menu model under Restaurant, which is the app's name. Next, open the menu, click on the Add Menu button. A new page will display and enter the details provided inside the zip file containing the text for the menu items. Staying inside the Django admin panel, click the menu under Restaurant and notice that a page displays the list of menu items. Once the menu items have been added, open the views.py file. Notice that the code for the view functions for home, about, and booking are already in place. Now create a view function for the menu page called menu and pass the request object as an argument. Inside the function body, create a variable called menu data and assign it the value of objects.all, which is called over the menu model class. Create a variable called main data and assign a dictionary that contains the following key value pairs: a key of menu as a string and the value of the menu underscore data as the variable. The final part of the view function is to return the render function from the view, making sure to pass the following arguments to it: the request object, the template name menu.html passed as a string, and the dictionary object with a string value menu as the key, and a variable main data as its value. Open the app level URLs.py and add the path function for the menu view. OK, so that should be all the code required to complete the model and view function for the menu items. The next step is to add the code for the template. Expand the app level directory templates and create a file called menu.html and add the starter code to it. After you insert the starter code, replace the comments with the appropriate Django template language code. First, create a for loop that will iterate over the menu object. Use a temporary variable called item as an iterator. Remember that menu is the key of the dictionary object you passed to the template from inside the menu view function. So you must use the dot operators inside the template while accessing any objects and variables from the object passed to the template from the view function. Between the enclosing paragraph tags, print the menu name from the item variable. Next, between the enclosing HTML span tags, print the price from the item variable. To add the currency symbol and the price formatting, prefix the opening curly bracket with the dollar symbol and suffix the closing curly brackets of the DTL variable with .00. Finally, insert the template tag to end the for loop. OK, so the first part of the project is complete. Let's run the development server to test it. Open the terminal and add the command to run the server. Copy the URL generated and click the browser preview button. Then, paste the URL into the browser address bar and press Enter. Notice that the home page of the Little Lemon website loads. Now it's time to move to the second part of the project and create the menu item page. First, open the file _footer.html and paste the code that was supplied to you. Then, replace the code inside the angled brackets of the image tag with the appropriate template code. Next, make sure to remove the angled brackets and save the file. The final step is to open the file base.html and locate the comment footer content. On the line underneath, add the include tag with the relative path of the footer.html file. Save the file and refresh the web page in the browser. Notice that the footer content now displays on the Little Lemon website. Now it's time to move to the final part of the project and test the form. On the Little Lemon website navigation, click Book. In the form that displays, enter the details such as your initials as the first and last name, the number of guests, and a comment. Press on the Submit button to send the form data. Next, back in VS Code, right-click on the database db.sql Lite3 and select Open Database. Notice that the SQLite Explorer option will be generated at the bottom of the Explorer panel in VS Code. Click on the arrow next to SQLite Explorer to expand its contents. Scroll down to the table restaurant _booking and click on the Show Table icon. Notice that the reservation form data you sent is stored in the database table. And there you have it. This concludes the video of the solution to the assessment. Congratulations! Welcome to Little Lemon Restaurant.